Dayanand Sagar University. Live the dream.
Yeah, dear students, you have your first hour as chemistry, which will be taken by Mr. Harish sir. Yeah, Harish sir, you can take over from here, sir. Thank you,
Yeah,
sir.
thank you very much, sir. Thank you.
Yeah.
Sir, can you please allow me to share the screen?
Yeah, sir.
Please.
Ali sir, where are you?
Yeah, good morning, everybody. I think everybody can see the screen and I'm audible to everyone.
Yes, Harish, you're audible.
Yes, sir. Thank you very much, sir. Yeah, let's start with the chapter solid state, one of the very important chapter from the physical chemistry. Okay. So before we go with the details of the solids, let's try to understand the general characteristics of solids. So in the solids, like the particles are having very close packing. So the reason for the close packing is, one could be, you can take it like intermolecular forces or interparticle forces, intermolecular force of attractions. So since the intermolecular force of attractions are high, the particles are very close to each other. This is high. And coming to the second parameter, which is going to decide the state of the matter, that is thermal energy. So in the case of solids, the thermal energy is going to be very less. This is low. So due to this reason, in the solids, you can see very small interparticle distance, small interparticle distance. And these are found to be very rigid. Okay. And just one second. Yeah, they have got a definite shape. They have got definite shape. They have got definite mass and volume. Since the particles are very close to each other, there is very less interparticle distance and they are almost incompressible. Because since the particles space, the space available between the particle is very, very less, you cannot compress the particle, compress the substance to a greater extent. So they are compressible to a very lesser extent. We can say that this is almost incompressible. And they have very low diffusion. So these are the different general properties of solids. Then coming to the solids, the solids are actually classified into two types. One is amorphous, other one is crystalline. First is crystalline. The next one is amorphous. So when it comes to crystalline and amorphous, one point you keep in mind, so that you can answer many questions regarding this. That is, in the crystalline solids, the arrangement is very neat and clean. The arrangement is very ideal. There is a regular arrangement of particles in the crystalline. So regularity in arrangement. Here in the amorphous, it is irregular. See, if you think of why this regular arrangement and irregular arrangement is seen in crystalline and amorphous solids, you can see the process of formation of a crystal or formation of a solid. You can take it like you are preparing a solid from a liquid. When you want to prepare a solid from a liquid, you will be bringing down the temperature of the system. As I bring down the temperature of the system, we are bringing in the intermolecular force of attractions. So if we give sufficient space, time, and room for the particles, then they get arranged in a very regular pattern. Like for example, if particles are in a random fashion like this, if I give sufficient time and freedom for this, they may get aligned like this, A, B, and so on. And if I do not give sufficient time and freedom for this, they may get arranged like A, B. Instead of A, you may get B, then A, B. There is some randomization in the arrangement. So the crystalline substances will have a very regular arrangement. It means here there is a lot of freedom for the particles to get aligned. So you can call these as the perfect crystals, perfect solids, whereas amorphous solids are called pseudo solids. Pseudo. Because the arrangement is not exactly what we are expecting. So these are called true solids. Then as the arrangement is keep on changing, so this will have a long range order. Okay, but when you come for the amorphous, this will have short range order. Okay, now the arrangement of the particles, since it is very regular in the case of crystalline, when you try to separate the particles, you can separate the particles at a particular temperature. So they have a sharp melting point. But when it comes to the amorphous, the particles are not arranged in a regular fashion. So for breaking the interaction between the particles, the temperature, like these interactions may not break at a particular temperature. It may break with a very small variation in the temperature. So they melt over a range. Okay, next is enthalpy of fusion. So enthalpy of fusion is here. Enthalpy of fusion is definite. It's a definite value. Here, it's not definite. Yes. Fine. That's regarding the amorphous and crystalline solids. So rest is like this gives plain surfaces with when cut using sharp edge tools, but amorphous will not give a plain and smooth surfaces when cut using sharp edge tools. So this is first type of classification and some important points regarding the classification of solids into crystalline and amorphous. These crystalline solids are further classified into different types. So they are, first one, molecular solids. Second one, ionic solids. Third one, it is metallic solids. And the last one is covalent or network solids. See, this classification is done based on the type of the interactions which are present between the constituent particles. If the interaction between the constituent particles is intermolecular forces, which are weak, then we call such solids as molecular solids. If the interaction between the particles is electrostatic force of attraction, then we call such solids as ionic solids. And if the interaction between the particles, constituent particles, is a metallic bond, then we call them as metallic solids. And if the interaction between the particles is covalent bond, then we call them as covalent solids or network solids. So since we know the intermolecular forces can be of different types, these molecular solids are further classified into different types. Like, one is non-polar molecular solids. Second one is polar molecular solids. And the third one is hydrogen bonded. Okay. When it comes to the non-polar molecular solids, here the interactions are weak London forces. Since the interactions are weak London forces, the materials are going to be very soft and they are having very low melting and boiling point. And even these materials do not conduct the electricity because they do not carry any, they do not contain any charge carriers. Then coming to the polar molecular solids, here the molecules, the constituent particles are going to have dipole interactions.
Harish, just a minute.
Yes, please, sir.
Can you use a different color?
Is it not visible, sir?
Visible, but it's not very clear. Yeah.
Okay, fine. But is it legible, sir?
Yeah, very much, very much.
Okay, fine. Yeah. So first one is polar. Sorry, I think it was non-polar I have written. Yeah. Non-polar. In case of non-polar, it is London forces, weak forces. So second one is polar. In the case of polar molecular solids, the interactions between the interactions between the particles is dipole-dipole interaction. So here also the materials are actually, the particles are held together by weak intermolecular forces. So the materials are going to be soft and they have a low melting point and boiling point, and they do not conduct the electricity. So sometimes the questions may rise from this part, like some material is a non-conductor of electricity, which is very smooth. Such kind of the properties they would be giving, and they'll be asking which type of solids they are. So it's better to know the properties also. Last is hydrogen bonded molecular solids. In this case, the interaction is going to be hydrogen bond. Fine. So that's regarding the molecular solids. When it comes to the ionic solids, here the constituent particles are ions, positive and negative ions, and the ions are held together by electrostatic force of attractions, as I've already told you. But one very important point to be noted here is regarding the electrical property, conducting property. These solids, ionic solids, they do not conduct the electricity in the solid state. In solid state, they do not conduct electricity. And the reason is also being asked many a times. In solid state, they do not conduct electricity because the ions are not free. Ions are not free because the ions are going to be in a fixed position. When they are in a fixed position, ions are the particles which are supposed to carry the charge. But since ions are in a fixed position, they cannot conduct the electricity in the solid state. But in the molten state, and in solution, they conduct. Okay, I hope this point is made clear for everybody. Yes, this is very important. Please note somewhere. Yeah, moving on to the next, that is metallic solids. So in case of metallic solids, the constituent particles are metal atoms, and between the metal atoms, there is going to be a metallic bond. Okay, the properties are important because the questions will rise from that part. Metals are going to be malleable. and ductile. They are good conductors. They are very good conductors. They have moderately high melting point. Okay. Sonorous, lustrous, all such properties can be included in this case. So that's regarding the metals. Then coming to the covalent, covalent solids are the network solids. The covalent solids, in this, the constituent particles are atoms. Usually they are non-metallic atoms. Okay, so between the two non-metallic atoms, there is going to be a covalent bond. So these materials are going to be very hard in nature. They are hard. They have high melting and boiling point, and they are insulators in general. So there is an exception when it comes to the graphite. Graphite is a conductor. It conducts the electricity. The conduction of electricity from the graphite is due to the electrons which are available between the planes. Okay. Yeah, that's regarding the classification of the solids. Now moving on to the actual concepts of the solids, that is unit cell. See, in a crystal, in a solid, the constituent particles will be placed in a certain position. The particles, when they are placed in a certain position, the point where we can place a particle in a crystal, that point is called as lattice point. These lattice points are going to be arranged in 1 dimension, 2 dimension, and 3 dimension, which will produce a lattice. And when you are joining the points, you are going to get some certain geometrical figures. Based on that, we are going to classify the different types of crystals, crystal lattice. So in that, a smallest portion of the crystal lattice, which when repeated in different directions, would generate a complete crystal. So this small part, if I keep on arranging it all 3 directions, it's going to generate the complete crystal. We call this one as the unit cell. And this unit cell will have different parameters, like you can say this edges A, it is B, C, and A. This is B, this is C, this is A. Then angle between the edges, like between B and C, this is alpha. Between C and A, it is beta. And between A and B, this is gamma. So we have 3 edges, A, B, and C. And angle between the edges, alpha, beta, and gamma. Okay. So depending, like by varying these parameters, that is alpha, beta, and gamma, A, B, and C, we can generate different types of crystal systems. So there are 7 different crystal systems. So knowing the properties of all these 7 different crystals is very, very important. The different crystal systems are cubic, tetragonal, orthorhombic, monoclinic. I prefer you learn in the same sequence because I'm going to give a trick for remembering this whole table. Triclinic, hexagonal, and rhombohedral. Okay, so these are the 7 different crystal systems. So if you want to remember this, you can just take the first letters of it: CU, TE, OR, MO, THER. Like CU stands for cubic, TE stands for tetragonal, so it makes cute. Orthorhombic, I'll write it as OR. UR, orthorhombic. M stands for monoclinic. MO stands for monoclinic. T stands for triclinic. HE stands for hexagonal, and R stands for rhombohedral. Yeah. Someone is asking me, sir, which solids have the van der Waals force of attractions? So that is the first one, like non-polar molecular solids. Okay. Yeah. So you can remember the different crystal systems just by this one. Okay. I prefer the same order. Why? Because other properties must also be learned here, like the possible variations. Here, edge length, then angle between the edges. Okay. See the possible variation, you can remember the number like 324211. Okay. Unit cell can be of different type. Yeah, someone is raising the hand. Yeah, yes, sir. Yeah, yes, Pooja, Pooja Hiremat, what's your doubt?
Sir, I guess she is answering for the question you asked, London force, sir.
Yes, sir, please.
Yeah.
May I wait for the questions or shall I continue, sir?
No, sir, you can continue, sir. In between, if the questions come, I'll just let you know about that.
Okay, please, sir. Thank you.
Yes, sir.
Okay, so possible variations, you can remember it like this: 324211. So where 3 is primitive, body centered, and face centered. So these three types of unit cells are possible in the cubic. In tetragonal, it is primitive and body centered. In the orthorhombic, it is primitive, body centered, face centered, and end center, all the four. In monoclinic, primitive and end center. And in the triclinic and other two, it is only primitive unit cells. Okay. Then coming to the edge length, you can remember it like this: A is equal to B, which is equal to C here. The second one, A is equal to B, which is not equal to C, means the one will be going off here. The third one is A is not equal to B, which is not equal to C. And coming to angle between the edges, alpha is equal to beta, which is equal to gamma is equal to 90 degree for this. Alpha equal to beta equal to gamma, which is equal to 90 degree. Same thing remains here. Alpha equal to beta is equal to gamma is equal to 90 degree. Same thing remains for these three. Okay, so it's very easy to remember these three, first three. So I'll tell you the trick for remembering the other three also. Okay, so for monoclinic, for only monoclinic, A, like this A is not equal to B, which is not equal to C, remains same. And for triclinic also, A is not equal to B, which is not equal to C, remains. Okay, you can come from the bottom. For rhombohedral, A is equal to B, which is equal to C, means the first one and the last one will have the same kind of parameters. Then second one, A is equal to B, which is not equal to C. Here also A is equal to B, which is not equal to C. Okay, so it remains the same. Then coming to the angles, like the triclinic is the most unsymmetric crystal system. So alpha is not equal to beta, which is not equal to gamma, which is not equal to 90 degree. Okay, so the most symmetric is this one. Most symmetric is cubic system, and most unsymmetric is triclinic. Okay, then coming to the hexagonal, alpha is equal to beta is equal to 90 degree, but gamma is equal to 120 degree. Please remember this. Remaining is easy. Okay, then rhombohedral, alpha is, can you hear me?
Yes, sir, you're audible, sir.
Okay, there is some small variation in network, that's why.
No, sir, you're audible, sir.
Okay, for monoclinic, alpha is equal to gamma is equal to 90 degree and beta is not equal to 90 degree. Fine. Then coming to the rhombohedral, so alpha is equal to beta, which is equal to gamma, which is not equal to 90 degree. Okay. I hope all the edge length and the angle between the edges can be remembered with this table. Is that made clear for everybody?
Sir, there are some
I think
doubts.
there are some questions.
Yes, sir.
So can we ask,
Uh,
can they ask possible variations for tests? Yes, of course. Sometimes they give some different parameters, like in some crystal system, A is equal to B is equal to C, alpha is equal to beta is equal to gamma is equal to 90 degree, which is the type of the crystal system A. Like they give different systems, crystal systems there. Okay. Yes, next, I think Shivani. So what is the difference between parallelogram lattice and rhombic lattice? There itself you can see the angles. Angles in the case of rhombic lattice is need to be same, right? But in the case of parallelogram, it need not be same. That's the biggest difference. Okay. Next, yeah, Yashonandan. Sir, what is C? I didn't get you. Like where you are asking for C? Like in which one?
sir, it's EE.
E. Yeah, what is E? E is asking. Where is E? Oh, from the shortcut. Okay, 1 minute. Just a minute. CUTE. This is cubic, tetragonal. Okay. OUR. This is orthorhombic. M, monoclinic. MO is monoclinic. Triclinic. HE, hexagonal. R stand for rhombohedral. Okay. Yes, I think it's answered. Yeah, P stands for primitive, dear. P stands for primitive, B stands for body centered, F stands for face centered, E stands for end centered. Yeah, let's move on. Let's not kill time here. Yeah, fine. So that's regarding the 7 different crystal systems. And if you see these 7 different crystal systems, there, if you count the total number of possible variations here, so there are 3 plus 2 plus 4 plus 2 plus 1 plus 1. So which comes out to be, the sum is coming out to be 14. These 14 are called as Bravais lattice. Okay, number of Bravais lattice are 14. So you can fit any crystal in this 14 Bravais lattice. Fine. So that's regarding the crystal systems. Then coming to the close packing in the crystals. When it comes to the close packing, we can classify these as 1-dimensional, 2-dimensional, and 3-dimensional. Okay. When it comes to 1-dimensional, the particles are going to be placed one after other like this. When the particles are placed like this, I mean each particle is going to be in contact with 2 particles. So the coordination number in this case is 2. Okay. When you want to arrange the particles in 2 dimensions, you can arrange it in 2 ways. This is a particle of 1 row. I'm going to place the particle of the second row exactly over this, like this. When particles are placed like this, if you try to join the center of the particles, it's going to give a square. So this is called square close packing in 2D. Okay. The other way of arrangement which is possible is like the particles of the first row. I mean, the particles of the first row are making some voids. I mean, let me write it like this. It's not visible properly. Yeah, check here. The particles of the first row, they are arranged like this. I'm going to place the particles of the second row on the depressions of the first row like this. When we place the particles like this, and if you join the centers, you are going to get a regular hexagon. So hence it is called hexagonal close packing in 2 dimension. Okay. So square close packing in 2 dimension, if you observe, each particle is in contact with 4 particles. So the coordination number is equal to 4. Here each particle is in contact with 6 particles. So coordination number is 6. So that's regarding close packing in 2 dimension. If you see for close packing in 3D, 3 dimensions. So we can make use of square close packing in 2 dimension layers, or we can make use of hexagonal close packing in 2 dimension layers. Both can be used. If I'm using square close packing in 2 dimension layers, and then it's as simple as this. So particle which are arranged like this. This is the particle of the second row. Okay. So we are going to place the particles of the second layer over it like this. When we place the particles of the second layer over the first layer, you connect the centers. You are going to get a simple cube, right? It's a simple cube. Hence it's called as simple cube packing. Next, HCP in 2 dimension, if you are placing, so the first layer and the second layer. So first layer is already available. We are going to place the particles of the second layer. When we are placing the particles of the second layer, make sure that they are placed covering triangular voids. So what is a triangular void? See, if you have a particles like this, 3 particles, the gap between these 3 is called triangular void. Okay. And if you have 4 particles, 3 particles aligned in one layer, the particles of the second layer is fit over this. This gap is called tetrahedral void. Okay. And if there are 3 particles like this, and if you place the particles of the second layer over this, this is called octahedral void. So the second layer particles are placed over the first layer covering the triangular voids. Then when you are placing the second layer, it's over. Then third layer, when we are placing the third layer, we have 2 options. One is covering tetrahedral voids. Another one is covering octahedral voids. If we cover the tetrahedral voids, the arrangement of the particle is going to be AB type. When it is AB type, we call it as hexagonal close packing in 3 dimension. Okay. Here the coordination number is going to be 12. And when we are covering the octahedral voids, it is ABC type of packing. Then this is called CCP or FCC. FCC unit cell it gives are called CCP, cubic close packing. So the coordination number in this case is also 12. Okay, so here the pattern of arrangement is very important. So CN stands for coordination number. Since we are running short of time, I'm just writing the shortcuts. Okay.
Excuse me, sir.
Yes, sir.
Sir, actually students have difficulty to see the board because it's black.
Is
They're
it?
asking to make it board white, sir.
Just 1 minute, sir.
Okay.
Yeah, okay, fine, sir. I'll use this one only.
Yeah, you can use it, and you can use a dark color, Harish.
Sir?
Any dark color, you can use it on whiteboard.
Is this okay?
Yeah, okay. Is it okay now, Anikesh?
Yes, sir. Maybe the upper light one can be more okay than this, sir.
Yeah.
Because it will be visible also.
No problem,
I will
Harish.
use white screen only, no issues.
Harish, what we can do is that
Yes, sir.
we can, Harish,
Yes, sir. Yes, sir. Please.
You
Sir.
can just give a brief insight to the synapses, because synapses they already studied. You
Okay.
can go to questions directly, solids and solutions.
Okay. Fine, sir.
Okay, okay.
So may I take another 5 or 10 minutes?
Yeah, you can take. You can take.
Yeah, sure,
definitely.
sir.
Yeah, for synopsis. Then I'll
Yeah,
give
right,
it.
right. No problem.
Okay, better I'll use some dark colors now onwards.
Yeah, yeah. No onwards you can use doctor. Yeah, black use it. It's good.
Yes, sir. Yes, sir. Yes, sir.
Yeah, right. Black will do, or red will do, I think.
Yeah, yeah, it will be okay. No, I thought like black will be more.
Yeah.
It's okay, fine.
No problem.
Yeah.
It was visible, but as he told, we'll go according to the student's request.
Okay, fine, sir, fine.
Yeah.
So that's regarding the close packing. Then here we will come across something called the packing efficiency. So packing efficiency is nothing but the fraction of the percentage of the unit cell available which is occupied by the particles. Packing efficiency. Okay. So the packing efficiency for simple cube, it will be 52.4%. This is packing efficiency. PE stands for. We have something called the void percentage. The void percentage is 100 minus this one, that is 47.6. Okay. Then we call something called packing fraction. So if you divide the packing efficiency by 100, that will be 0.52. For this is the packing fraction. Similarly, if we go for body centered BCC, the packing efficiency is going to be 68. The void fraction is going to be void percentage is going to be 32, and the packing fraction is going to be 0.68. Then FCC, then packing efficiency here in this case is 74. Void percentage is going to be 26. Then packing fraction is 0.74. So please note these values. These are important. Yes. Moving on to the defects. I'll just take another 5 minutes for completing my synopsis. Just 5 minutes. Yeah. Coming to the defects, there are different types of defects. So the defects can be classified mainly into two types. One is point defect. Another one is line defect. In the case of point defect, like we will not be learning in detail about the line defect. In the point defect, this can be further classified into different types. One is vacancy defect. Another one is interstitial. In case of vacancy defect, some particles will be missing from the lattice position. In case of in case of interstitial defect, some particles will be going into the interstitial side. Then in this point defect, if you see for ionic compounds, this can be classified into three types mainly. One is stoichiometric defect. One is stoichiometric defect. Second one is non-stoichiometric. And third one is impurity defect. Okay, so the stoichiometric defects are those in which the composition of the ionic compound is not going to be changed. The ratio of the cation and anion is going to be same, even though there is some defect introduced into the crystal. So the stoichiometric defects are further classified into two types. One is Schottky, another one is Frankel defect. Then coming to non-stoichiometric defect, here there are two types. One is metal excess. Second one is metal deficiency. Okay, so metal excess defect, it can be due to anionic vacancies. Second one, it can be due to extra cation in interstitial site. Metal deficiency, it is due to cationic vacancies. Second one, it can be due to extra anion in interstitial site. Okay, fine. So please have a look on these different types of defects. Yeah, Pragna, I will come to that. I'll come to that when I'm going to solve the questions. So next is regarding the electrical properties. See, the substances can be classified into three types. One is conductor. Second one is insulators. And third one is semiconductors. So I think everybody knows these definitions, but semiconductors are classified into two types: intrinsic and extrinsic. So intrinsic semiconductors and extrinsic semiconductors. So that is pure semiconductors. They are also called as pure and doped. Pure means in the free state, like in however it is available in the natural state, that is being considered. And in the doped case, we are going to introduce some impurities. So doped semiconductors are further classified into two types. One is N type, another one is P type. So for pure semiconductors, you can take germanium or silicon. Okay. In case of N type semiconductors, holes are the majority charge carriers. Okay. Here the holes are the majority charge carriers, and these are obtained due to doping 13th group elements with 14th group. Okay. P type, these are here the majority charge carriers are the electrons. So electrons are the majority charge carriers. And these are obtained by doping 15th group elements. So 13th group elements are also called electron deficient. So 15th group elements are electron rich. Okay, I hope you got some idea regarding the semiconductors. Okay. Yes, then let's go to the questions, solve questions. Is solving PQYS is enough, sir? I didn't get you. What is PQYS? HX3? Fine.
Sir, previous year question papers. Sir.
Okay. Fine. No. Previous year question paper will give you an idea like what type of questions may appear in the CET. Okay. Yeah. So the different content that you are supposed to focus on, that you will get an idea, but not the same questions will be repeated here. Okay. So let's go with the questions. So question number 1, I think it is visible to everyone.
Yes, sir. It's visible, sir.
Okay. Sir, in KCET, they ask example for crystals. Sometimes, see, when we go with the questions, you will get to know. In some part, they are asking like what are the different like type of crystals, like by giving the dimensions. Yeah, CN whatever I had written there, that is coordination number. Yeah, coordination number is the number of particles which are in direct contact with a particular particle. Okay. Yes, let's go with the questions. A crystalline solid XY3 has CCP arrangement for its elements Y and X. Y, X occupies. See here, they have given in the question, like in a crystal solid XY has a CCP arrangement. for its elements Y. So since Y has a CCP arrangement means number of particles of Y must be equal to 4 because that is forming the CCP. CCP is nothing but FCC. Number of particles per unit cell in FCC is 4. So I can take the number of particles of Y is equal to 4. Then number of octahedral voids. Number of octahedral voids will also be equal to 4 because number of particles will be equal to number of octahedral voids. Now they are asking about the X. Where does this X occupy? And number of tetrahedral voids will be 8. Okay. Now, like the formula of the compound is given XY3. XY3. It means X and Y are in the ratio 1:3. So suppose if I take Y to be 4, if Y is 4, then X is going to be 1/3 of it. So 4 into 1/3. Are you getting that? If Y is 4, then X has to be 1/3 of this one. Okay, then only we can cancel this 4 and 4 and this 3 comes here, this part. Okay. Yes, are you getting that? Okay, someone was asking me regarding this slide. Just 1 second. It has to be P type and N type. Okay, I have to interchange this. Yeah, someone wanted this packing efficiency slide. Just 1 second. Yeah, Madhu is asking me, sir, Schottky defect decreases the density, but why? Still it is stoichiometry because the simple whole number ratio of the cation and anion is not going to be changed even though the density is decreased. So the stoichiometry of the compound is not disturbed. The ratio of cations and anions is not disturbed. That's why it is considered as a stoichiometric defect. Okay. Antimony squad, I think, yeah, that's changed. That's changed. It's completed, I think. Yes. Fine. Then I'll go with the next question. So I will complete this question first. Okay. So to get this formula XY3, I'm supposed to transfer this 3 here. 4 will get cancelled. So 4 is the number of octahedral voids and 1/3 of it is filled. So 1/3 means it is nearly about some 33% of octahedral void is filled. Okay. So this is the number of particles. This is the number of octahedral voids. Number of octahedral voids. And the fraction of it is 1/3 is being filled. So if you take, like you may ask me, sir, why can't I take tetrahedral void? If I take tetrahedral void here, then it has to be 1/6 it will be filled because here it is going to be 8, right? To get this formula XY3, 4 into 1/3 need to be taken here. So 4 is the number of octahedral voids and the fraction is 1/3 is being filled. So therefore, this is the formula. Yeah, in N-type semiconductors, the electrons are the majority charge carriers. See, you can remember this N-type and P-type without any confusion. Like the majority charge carriers are holes. holes will have positive charge. Positive means starts with P, so they are P-type semiconductor. Here the majority charge carriers are electrons. Electrons have got a negative charge. So when they have got negative charge, that's N stands for N-type semiconductor. Okay. I hope your question is answered. Yeah, fine. Yes, so the answer for this question is yes, 33% of the octahedral voids has to be filled. Okay. Next, question number 2. Volume occupied by a single cesium chloride ion pair in a crystal is 7.014 into 10 power minus 23 centimeter cube. This is the volume. The smallest cesium internuclear distance is equal to length of the edge of the cube. Length of the edge of the cube. So corresponding to volume of one cesium chloride ion pair, the smallest cesium to cesium interaction distance is nearly. See, what they have given is the volume A cube. A cube is equal to 7.014 into 10 power minus 23. And they are asking us to calculate the cesium to cesium distance, internuclear distance. And here they have given the details like the smallest cesium to cesium internuclear distance is equal to the length of the edge. So cesium to cesium distance is equal to edge length. So A is equal to, you can take the cube root of this. Cube root of 7.014 into 10 power minus 23. When such large numbers are there, it's a bit difficult to handle them. Then A is equal to cube root of, take it as 70.14 into 10 power minus 24. Okay. So then A is equal to, so cube root of 70. So we know 4 4s are 16, 16 4s are 24. So cube of 4 is 64. Then it must be very close to 4 because 5 cube is very larger than this. So it must be the answer is nearly about some 4. So the answer will come out to be, yes, what? 4 point, actually it is 4.12 into, so 10 power 24 by 3 is 10 power minus 8. This is in centimeters. Convert this into meters. It will be 4.12 into 10 power minus 10 meters, or I can write it as 4 angstroms approximately. Okay. So the answer is option C. Yes. Next. I hope this is clear. Let's go to question number 3. Yeah. So here is the question. The reason for you to remember that table, asking you to remember that table is this. See, check here. The unit cell with crystallographic dimension A is not equal to B, which is not equal to C. Alpha is equal to gamma, which is equal to 90 degree. But alpha is equal to gamma is equal to 90 degree, but beta is not equal to 90 degree. So these dimensions, you have seen it for monoclinic, right? So let's go back to that if you want. Let's check here. Yes, in the monoclinic, you observe A is not equal to B, which is not equal to C, alpha is equal to gamma is equal to 90, and beta is not equal to 90 degree. So the answer for this is monoclinic, option A. Okay, fine. Next, sodium metal crystallizes in, this is BCC lattice. There is some small typing error. This is BCC lattice with edge length of 4.29 angstrom. Okay, the radius of the sodium atom is, okay, so for a BCC, we know that A is equal to 4R by root 3. Okay, edge length is equal to 4R by root 3. Therefore, root 3 into A must be equal to 4R. They are asking us to calculate the radius of the sodium atom. Therefore, R must be equal to root 3 into A by 4. So, root 3 value, it's better if you remember 1.732. 1.732 into edge length. Edge length is given as 4.29 divided by 4. The value, if you simplify this, the value comes out to be 1.857 angstroms. So check for the units of the edge length given here and the units of the radius given here. If they are same, then you can go with it, or else you may have to go with conversions. So the answer is 1.857, option B. You can simplify this and check the answer. Next, question number 5. The contribution of a particle at the edge center of a particular unit cell. See, edge center is this position. Edge center is this position. This is in contact with a unit cell here, which is present adjacent to this, and this particle is in contact with one more unit cell which is present here, and it is in contact with one more unit cell which is present next to it here, right? So this one particle is being shared by 1, 2, 3, 4 unit cell. So the contribution from this particle to this unit cell is 1 by 4. For this unit cell is 1 by 4. For this it is 1 by 4. For this it is 1 by 4. So a particle present at the edge center position contributes 1 by 4 to the unit cell. Okay. Yeah, I can discuss the structure of NaCl, cesium chloride, fluoride, antifluoride, all such, but time is the constraint. Okay. Fine. Let's move on. Question number 6. Schottky defect in a crystal is observed when? See, when you want to see this Schottky defect, the condition is the number of cations and anions are going to be, which are leaving the lattice are going to be same number, or you can say the net charge by the loss of the ions has to be 0. Means there must not be any charge which is raised in the crystal due to the loss of some particular ions. So here equal number of cations and anions are missing from the lattice, as we know about the Schottky defect. So answer is option B. The correct statement regarding the defects in solid is Schottky defect has no effect on the physical properties of solids. Yes, actually Schottky defect will decrease the density of the solids, but they have given it as Schottky defect has no effect on the physical properties of solids. So this is a wrong statement. Frankel defect is a dislocation defect. Of course, in the Frankel defect, what is going to happen? If you have cations and anions, positive, negative, positive, negative, and if you have negative, positive, negative, positive, like this. So the cations, the smaller ions, usually the cations, they are moving from their position to interstitial position. Means it is going from this position to this position. So this is a dislocation defect. So this is a right statement. Then Frankel defect is usually favored by very small difference in the size of the cations and anions. No. See, the cation and anion, like this Frankel defect, as I said, this is the cation is moving from its position to interstitial side. When there is a large difference, this cation can fit into the voids, interstitial sides, or else this cation is also of the anion size, it cannot fit into the interstitial side. So the size must be very large. There must be a large difference in the size, but here they are saying small difference, so that's the wrong statement. Trapping of proton in the lattice leads to the formation of F center. No, trapping of electrons leads to the F centers. Next, question number 8. of the following crystal systems has unit cells such as A is not equal to B, which is not equal to C, alpha is not equal to beta, which is not equal to gamma is equal to 90 degree. This is being exhibited by triclinic unit cell. Triclinic. For triclinic, the example is K2Cr2O7, potassium dichromate. Okay. Then next, question number 9. In a face-centered cubic arrangement of A and B atoms, in which A atoms are at the corner of the unit cell. So, ilnodi itara questions bandre. Like if you come across such questions, take the ratio of the elements A and B. Okay. So, in a face-centered cubic arrangement of A and B, A atoms are at the corners of the unit cell. So, A are at the corner of the unit cell. So, 8 corners will be there in one unit cell, and each one contributes 1 by 8. And B atoms are at the face centers. So there are 6 faces, and each particle at the face center contributes 1 by 8. Therefore, 8 into 1 by 8 is 1. 6 into 1 by 2 is 3. So the formula of the compound they will be asking. But here, what has happened? Some particles are missing from the lattice. So the second part of the question you observe, one of the A atoms is missing from one of the corner in the unit cell. So we were expecting 8 particles at 8 corner and each one contributing 1 by 8, 6 particle at the face and each one contributing 1 by 2. Since a particle is missing from here, instead of taking 8, you take 7 here. So it's going to be 7 by 8 is to 3. So make it a simple whole number. How can we make it? Multiply it by 3 and divide it by 3. So you get, multiply it by 8 and divide it by 8. Three multiplied by 8 divided by 8. Okay, so you will get 8 will get cancelled here. Okay, sorry, I can take it like multiply 8 on both sides. Sorry, 7 by 8 into 8 is to 3 into 8. So 8 gets cancelled. So 7 is to 8 3 is 24. So the formula of the compound is A7B24. Yes, I hope this problem is also made clear. Yes, so the answer for this question number 9 is B, A7B24. Next, moving on to question number 10, which of the following oxides shows electrical properties like metals? So you can note these metals. These metals shows properties of electrical properties very similar to that of metals, like CrO2, chromium oxide, TiO, titanium oxide, and ReO3, rhenium oxide. So these three shows properties very similar to that of metals. So among these three, the chromium oxide is given CrO2, so you can mark it. In FCC, the unit cell is shared by equally by how many unit cells? So this is let us consider a FCC unit cell. FCC or any unit cell. This unit cell will be in contact with one unit cell this side. This is in contact with another unit cell on this face. It is in contact with one more unit cell on the front, one unit cell at the back, 4, one unit cell at the top, 5, one more unit cell at the bottom, 6. So each unit cell, FCC unit cell, is in contact with 6 unit cells. So therefore, answer for this is 6th one. Next, question number 12. Edge length of the cube is 300 picometer. Its body diagonal would be. Okay, so you can take these formulas. Body diagonal. Body diagonal is given by the formula root 3 into A. face diagonal can be calculated using the formula root 2 into A. Okay. Yeah. So here in this case, in the given case, the edge length is given as 300 picometers. Body diagonal is being asked. Body diagonal is equal to root 3 into A. So root 3 is 1.732 into 300 picometers. So the answers are also given in picometers. So you need not convert them. So into 300 picometers. If you multiply these two numbers, you may get nearly about 519.6 picometers. Okay. Yeah, someone is asking me, sir, how is tetrahedral is 8? Tetrahedral is going to be 8 because number of particles are 4. If number of particles are 4, number of tetrahedral voids will be 8. Okay. So that's why we cannot take it in the first problem. Okay. Just 1 second. Someone is asking me to repeat the fourth question. Question number 4. Okay. Sodium metal crystallizes in BCC lattice with an edge length of 4.29 angstrom. Radius of the atom is. It's very simple. So it's a repetition. Just fourth one, somebody asked me to repeat it. So we know that for a BCC, A is equal to 4R by root 3. Okay. So R is equal to root 3 into A divided by 4. What's the value of root 3? 1.732. Edge length is 4.29 divided by 4. If you simplify this, the answer is 1.857 angstrom. Okay. Yeah, you can like for examples for crystal systems, you can follow the NCERT textbook. That is more than sufficient. Yeah, someone is asking for second question. See, if I go back for the questions again and again, I can't complete the material. Okay, someone is asking me for second one. Yeah, it's very simple. A cube is equal to the unit cell dimensions are given, the volume of the unit cell is given. They're asking us to find the CS distance. CS distance is nothing but the length of the edge. So A is equal to CS distance. That's given in the data. So A cube is this value. So take the cube root of this, you will get the A value. That I have already solved. Okay, so you can check the answer. Yeah, questions does not repeat every year, but sometimes a pattern of questions may repeat. Okay, so next question number 13. Question number 13, which of the following is not a conductor of electricity? So I told you in the solid NaCl, what's going to happen? The ions are going to be in a fixed position. When they are in a fixed position, they are not in a position to conduct the electricity. So solid NaCl is an insulator, which does not conduct electricity. Which of the following is a network crystalline solid? That is question number 14. So when I was telling you about the network or the covalent solids, constituent particles are going to be the non-metallic atoms, right? So in this, you can consider the non-metallic atom and a non-metallic atom. There must be a network kind of structure. So here iodine is forming a molecule. So this is a molecular solid. AlN3, this is a non-metal which forms a kind of network. So this is a network solid. This is the answer for it. NaCl is an ionic. Ice is a molecular solid. So there is some disturbance.
Ali sir, your mic is on, sir.
Yes, question number 15. Let's move on. The number of atoms in 2.4 grams. Yeah, this I was supposed to explain for everybody. See, The number of atoms in 2.4 grams of body-centered cubic crystal with edge length of 200 picometer is. See, for such questions, usually people will go with a long method. It takes a lot of time. This will be done in 3 ways. But the easiest way, which I feel, is whenever the molar mass M, whenever we take M is equal to molar mass, then Na is the number of particles. We know that, right? So in such problems, if M is equal to mass, small n is going to be the number of particles in the formula of density. So we know the formula for density, D is equal to Zm divided by A cube into Na, right? But when they are asking for some different mass, check here, 2.4 grams of material, and they have not given the molar mass, then in such cases, in the place of M, you take small m, and in the place of Na, you take small n. Small n can be anything. It need not be the Avogadro number. And here what they are asking is the number of atoms. So let's change the formula and get the answer very quick, very soon. How? This D is equal to Z into small m divided by A cube into small n. Okay, so we are asked to calculate small n. So Z into M divided by A cube into D. Z, see, they are saying it is a body-centered cubic crystal. So for body-centered, Z is equal to 2. And here you need not consider the molar mass. Take this mass, 2.4, divided by A cube. A is 200 picometer. If you convert it into centimeter, it is going to be 2 into 10 power minus 8 centimeter. Okay. Then 2 into 10 power minus 8 whole cube into density is given as 10, I think. Yes, density is 10 gram per centimeter cube. Just simplify this. N is equal to 2 into, I can write it like 2 into 2 into another 2 into 0.6, okay, divided by 2 into 2 into 2, that is 2 cube, into 10 power minus 24. Okay, so this 3 twos can be cancelled. So, and here we have about 10. So the value is N is equal to 0.6 into 10 power minus 24 into 10 is minus 23. If it comes to numerator, plus 23, or I can write it as 6 into 10 power 22. So you don't go with the longest method. This is the easiest and the simplest method. Okay. Yes, someone is asking me, sir, in problem number 6, why did we take 6 into 1 by 2? Just 1 second. No, problem number 9. Yes, dear, see here, the particles of B are going to the face center position, face center. So there are going to be 6 faces. So I'm taking 6, and each particle is contributing 1 by 2. So 6 into 1 by 2. Yes. Fine. Let's move on then. That's about question number 15. The answer is 6 into 10 power 22. We are left with another 4 questions. Sir, shall I go with these 4 questions or shall I go to the next chapter?
Harish, you can go to next chapter. No problem.
These 4 questions, shall I leave it to them?
Yeah, let them do it. Let them.
I'll take up this at least 17th one.
Yeah, please, no problem.
Yeah,
your wish, no problem.
Yes, because they find it difficult in answering this. Just one second.
Yeah, right.
This type of questions appear in CET as well as in NEET. So please check this. Question number 17, bit tricky. Suppose like this is regarding the non-stoichiometric defect. it is given like M 0.960. Okay. So, and M is existing as +2 and +3 state. They are asking us to calculate the percentage of M +3. Okay. In such cases, so it's very easy if you are converting these numbers into the whole numbers. So what I do, I'll make it as M96O100. Okay. And the charge of each oxygen is -2. The charge of each oxygen is -2. So the total net charge which is rise due to all the oxygen is -200. Okay. The total charge is -200. That -200 has to be balanced by the cations. So the charge of the cation is +200. To have +200 charge, both M plus and M+2 and M+3 ions are existing. So let us say number of M+2 is equal to X. Then number of M+3 is equal to the total number minus X. 96 minus X. Okay. If you have 96 ions, out of that X are M+2 and 96 minus X are M+3. All these ions are generating the charge, and that charge must be equal to +200. How? See, check this. X number of ions are generating +2 charge. So X number are generating +2 charge plus 96 minus X. 96 minus X number of charges are generating +3 charge. +3 charge. Okay. Which must be equal to total charge, net charge, that is 200. So I can simplify it. So we get 2x plus 96 into 3. Okay. 2x plus 96 into 3 minus 3x is equal to 200. Okay. Yes. Now the next step is very simple. Yeah. What are we supposed to do? So simplify this. This, if you take it to the other side, it's going to be X. X is equal to X is equal to, am I audible? Yeah, it's 288
Yes,
minus 200. 96 into 3 is 288. So 288 minus 200 is 88. X is equal to 88. Now the number of M+2 is equal to 88. Number of M+3 is equal to 96 minus 88. So it's going to be 8. I mean, nearly about some 8. Yeah, 08. So now you are supposed to calculate the percentage. How do you calculate the percentage? Percentage of M+3 is equal to number of M+3 is 8 divided by total number is 96. We just multiply it by 100. You will get the answer. Got it, everybody? Yes. So this pattern of question do appear in examination many a times. So what's the answer? It's going to be 8.33%. Yes, okay. So someone is asking me, sir, can you please explain the question again? So check here. They have given the formula of the compound is M 0.96O. Okay. So for our convenience, I'm multiplying these by 100. So you get M96O100. Okay. All these oxygen atoms are generating the total charge minus 200. So all these 96 ions are generating plus 200 charge. Okay. So out of this plus 200 charge, some charge is generated by m plus 2, some charge is generated by m plus 3. Okay. So now suppose let us say this is x number, then this is going to be total is 96. 96 out of 96, x is m plus 2. So m plus 3 means 96 minus x. Now, so the net charge generated by the positive ion is plus 200. So if you take it like it is 2 into x, because plus 2 charge into x plus 96 minus x into 3, because the charge generated is 3, which is supposed to be equal to 200. So if you simplify this, you get x is equal to 288 minus 200. X is equal to 88. If x is equal to 88, m plus 2 are 88, and take the difference, you get m plus 3 is equal to 96 minus 88, which comes out to be 80. Then percentage of m plus 3 is equal to, number of m plus 3 is 8 divided by total number is 96. Just multiply it by 100. You get 8.3%. Okay. Yes. So that's regarding the chapter solid state. So please do practice the same kind of problems, like many a times these are appeared. And so shall I move on to the next chapter? Ravishankar sir?
Yes, sir, please. Yeah.
Okay,
Sir, Ravi
fine.
Shankar sir is not there in the meeting right now.
Okay, fine, sir. Fine. Okay, fine. So let's go with the next chapter then. So the next chapter which we are going to discuss is the solutions. This is also one of the very important chapter from point of view of CET examination. So solutions. So solutions are going to be decided based on their physical state of the solute and the solvent. Solute is the one which is smaller in concentration, smaller in amount. Okay. And solvent is the one which is larger in amount. Fine. So solute and solvent. Now this solute can be in the solid state, liquid state, gaseous state, and also solvent can be in the solid, liquid, and gaseous state. Based on the physical state of the solvent, we are going to define which type of solution it is going to be, a liquid solution or a solid solution or a gaseous solution. Okay. So later we will be going with the different concentration terms. The different concentration terms that we are using here is mass percentage, mass of the component, divided by mass of the solution multiplied by 100. Similarly, volume percentage, volume of the component divided by volume of the solution into 100. Next is mass by volume percentage, mass of the component divided by volume of the solution multiplied by 100. Here we use some small like the concentration terms for the quantities if they are present in very lesser amount, that is ppm, that is mass of the component or volume of the component divided by mass of the solution. The whole thing will be multiplied by 10 to the power of 6. So in case of percentage, we'll be multiplying by 10 power 4. In case of ppm, we'll be multiplying it by 10 power 6. And coming to ppb, mass of the component divided by mass of the solution and multiplied by 10 power 9 instead of 10 power 6. This is ppb. And please note, the concentration terms, some concentration terms depends on the temperature and some concentration terms does not depend on the temperature. Okay, so here whichever the term involves the volume, that is temperature dependent. It depends on the temperature because volume do change with temperature. And if it does not involve the volume term in this, that will be temperature independent. Like you can go with mass percentage. Mass percentage is independent of temperature. Okay, the other concentration terms that we use are mole fraction. So mole fraction is nothing but number of moles of a component divided by sum of number of moles of all components. Suppose there are two components A and B in the solution. Mole fraction of A is equal to number of moles of A divided by number of moles of A plus number of moles of B. Similarly, mole fraction of B is equal to number of moles of B by number of moles of A plus number of moles of B. Okay, and please note the mole fraction, the sum of the mole fraction of all the component will always be equal to 1. And mole fraction of a component in a system cannot be greater than 1. Okay, ppm means parts per million, ppb means parts per billion, parts per million and parts per billion.
Excuse me, sir.
Yes, sir.
Yes, sir. I was telling that some students are noting down the notes. So
Okay.
they just.
Sir, shall we do one thing?
Yes,
I'll give some time at the end for them to take.
yeah.
The
Okay, sir. Okay, that will be fine, sir.
That will be fine. I think
Yeah,
I
sir.
can give all the slides at the end.
Sure, sir.
Okay. Yes, that's regarding the mole fraction. I mean, sum of the mole fraction of all the components must always be equal to 1. Okay. Then next concentration term is, see, here I'm going to use a convention. Wherever I am writing A, that refers to solvent. Wherever I am writing B, that refers to solute. Okay. Now, so let's go with the concentration term molarity. Molarity is nothing but given by the formula, okay, NB, number of moles of the solute divided by volume of the solution. Or the other formula, very important formula, is WB divided by MB into V in ml. You can take it like directly like this into 1000. This is the formula for molarity, where WB is mass of the solute, MB is molar mass of the solute. Okay, and V is the volume of the solution. The next concept, I mean, here we get 3 different cases. One is for dilution. When you dilute the solution, molarity of the final solution will be equal to M1V1, molarity of the first, I mean, initial solution into volume of the initial solution divided by V1 plus V, that is volume of solvent added. Okay, that is about dilution. Like when you are mixing two solutions of the same components, then molarity of the final solution will be equal to M1V1 plus M2V2 divided by V1 plus V2. This is the molarity of the final solution. And for reactions, how do we use this? See, for example, suppose there is a reaction H2SO4 reacting with 2 moles of NaOH. We get Na2SO4 plus 2H2O. Okay. Then for such solutions, how do we use the concentration terms? Molarity of H2SO4, volume of H2SO4, the reactants only we are going to take, divided by the stoichiometric coefficient behind this H2SO4 need to be considered here. That is 1, which is equal to molarity of NaOH, volume of NaOH divided by the stoichiometric coefficient present here is 2. So take it in the denominator. M of H2SO4, V of H2SO4 by 1, M of NaOH into V of NaOH by 2. Yes, the next concentration term is molality. Molality is equal to WB into 1000 divided by MB into WA. This is taken in grams. Okay, fine. So here molality does not involve any volume terms. So this is temperature independent. It is temperature independent. Okay. Next is normality. Normality is equal to WB into 1000 divided by EB into V in ml, where EB is equivalent mass of solute. Fine. That's regarding the normality. Yeah, in the case of normality also we find three different situations. One is dilution. Normality of the final solution is equal to N1V1 divided by V1 plus V. This is V is the volume of solvent added for diluting. Okay, then second thing is very similar when we are mixing two solutions. Normality of the final solution is equal to N1V1 plus N2V2 divided by V1 plus V2. In third case, if it is in the case of reactions like neutralization reaction, I'll take the same reaction. H2SO4 plus 2NaOH will give Na2SO4 plus 2H2O, right? So here normality of H2SO4, volume of H2SO4 will be equal to normality of NaOH into volume of NaOH. So in these conditions, when we are taking the normality, you need not take the stoichiometric coefficients. Yeah, molarity decreases with increase in the temperature because volume is in the denominator, right? Yes, what is mean by WB? I told you, like B is representing the solute. WB means mass of the solute. Mass of the solute. Okay, that's regarding the normality. So these are the different concentration terms we are using. Okay, next the solutions. We will be learning something called the solubility. Solubility of gas in liquid. Coming to solubility of gas in liquid, so consider a liquid. We are supposed to dissolve some gas in it. When these molecules are coming in contact with the surface of the liquid, then only they can get into the solution. Okay, so when we are applying pressure on it, on applying pressure, more molecules will come in contact with the liquid, so more molecules can get into the solution. So on applying pressure, on increasing the pressure, solubility of gas increases. So solubility we are going to measure using the what? Exactly. So solubility can be measured by using the mole fraction of the solute. So on increasing the pressure, solubility increases, and P is directly proportional to solubility, or P is directly proportional to mole fraction of the solute. Okay, then P is equal to Kh into mole fraction of the gas. In this case, gas is the solute, so gas. So this is called as Henry's law. Please note, pressure is directly proportional to mole fraction of the gas. And what is this KH? KH is the proportionality constant, and this proportionality constant depends on nature of gas and temperature. If you change the temperature, KH value changes, and if you change the gases, then KH value will also change. So I think you have studied about the applications of this Henry's law also. So that's regarding the solution of gas in liquid. Now, solution of liquid in liquid. If the interaction between let me consider two liquids, is liquid A and another liquid B. Okay, if I mix these two liquids, I'm going to prepare a solution. The interaction between A and A, the interaction between B and B, if the interaction between A and A is very similar to B and B, then these two will mix up very thoroughly and it is an ideal mixing. Therefore, if the interactions are same, then we call that such solution as ideal solution. For ideal solution, it will be following the Rolle's law and the interactions are same. Interactions are same. Okay, that is interaction between AA is equal to interaction between, almost equal to interaction between BB. It's almost equal to interaction between AB. Okay, then non-ideal solution is not going to be equal. And here in the case of ideal solution, delta H mixing is equal to 0. Delta V mixing will be equal to 0. Means there is no change in enthalpy on mixing. There is no change in volume on mixing. And one more point to be added, delta S mixing will be greater than 0, because when you are mixing two different liquids, in a way you are introducing some defects. I mean, in a way you are introducing some randomness in the system. So in case of preparing the solution, whether it is ideal or non-ideal solution, delta S mixing will be greater than 0. Okay, then coming to delta G. So this is a spontaneous process. It will mix up spontaneous. So delta G will be less than 0. And if it is not having the same kind of interactions, then we call them as non-ideal solutions. Okay, so non-ideal solutions, we can have two types. One is non-ideal solution with positive deviation, non-ideal solution with negative deviation. In case of non-ideal solutions with positive deviation, interaction between AB is weaker than interaction between AA and BB. When the interactions are weak, more molecules will be in the gaseous phase. So delta H mixing will be greater than 0. And delta V mixing is also greater than 0. Delta S mixing will always be greater than 0. In the case of negative deviation, interaction between AB is greater than AA and BB. When the interaction between the process is greater, then delta H mixing will be less than 0, means it is an exothermic process, and delta V mixing will also be less than 0, negative value. Okay, so in this case, you can consider like, you can answer it in terms of like Rolle's law, that is P total will be for positive deviation greater than P naught of A into mole fraction of A plus P naught of B into mole fraction of B. In this case, P total is less than P naught of A into mole fraction of A plus P naught of B into mole fraction of B. Okay, so this is regarding the positive and negative deviation. So next is about the colligative properties. Yeah, when it comes to the colligative properties, they depends on number of particles, but not on any other parameters. So such type of properties are called. The properties which mainly depends on the number of particles, not on the nature of the particles, they are called colligative properties. So in the colligative properties, we have different like RLVP, relative lowering in RLVP, relative lowering in vapor pressure. So then elevation in boiling point, relative lowering in vapor pressure, elevation in boiling point, next depression in freezing point, and last one is osmotic pressure. So we have derivations for all these things, like how they are going to be vary with the number of particles and such things. But I am going to give the formulas directly. P naught of A, that is vapor pressure of pure solvent, minus P divided by P naught of A is equal to mole fraction of solute. That is WB divided by MB into WA into MA. It's an approximated value. You can take it directly like this, or like next elevation in boiling point, delta TB is equal to KB into molality, that is KB into WB divided by MB into 1000 divided by WA. This has to be taken in grams. Similarly, delta TF is equal to KF into molality. So KF into WB into 1000 divided by MB into WA. This is taken in grams. Okay. Next is this is relative lowering in vapor pressure. This is elevation in boiling point. This is depression in freezing point. Then osmotic pressure, which is given by pi. Pi is equal to C into RT. That is nothing but M into RT you can take if it is a molar concentration. So we know that M is equal to WB divided by MB into V. If you are taking in ml, then just R into T multiplied by 1000. Okay. Fine. So this is regarding the different colligative properties and their formula for calculating the molar mass and other quantities. Okay. So here we come across something called the Van 't Hoff factor. So this Van 't Hoff factor, I, it depends, like it is observed only when there is association or dissociation. Means the solute what you are considering, if it undergoes association in the liquid or if it undergoes dissociation in the liquid, then we are going to make use of this factor, that is Van 't Hoff factor. Okay, whenever there is association, this I value will be less than 1, and when there is dissociation, this I value is greater than 1. Okay, so here we come across two more things, that is a degree of dissociation. We can calculate from the Van 't Hoff factor. Similarly, we can calculate the degree of association. So degree of dissociation, alpha is equal to I minus 1 divided by n minus 1. Degree of association, alpha, is equal to I minus 1 divided by 1 by n minus 1. Okay. So note these formulas. These are very important. Yes. How can we know that a solution is undergoing association or dissociation? So there are some examples given in the NCERT, so you can go with that. And also, whenever you consider any ionic solids are likely to get dissociated in the liquid. So if any ionic compounds are given, 100% they are going to have some kind of dissociation. If some molecular compounds are given, something like glucose, urea, such things, they do not undergo association or dissociation. Whenever there is a kind of dimerization or a trimerization or a formation of a polymer, then you can see this association. Okay, fine. So let's go with the questions. Yes, which of the following is not a colligative property? See, elevation in boiling point is a colligative property. Depression in freezing point is a colligative property. Then osmotic pressure is a colligative property. Lowering of vapor pressure is not a colligative property. In fact, relative lowering is the colligative property. The difference is lowering in vapor pressure is P naught of A minus P. This is not a colligative property. P naught of A minus P divided by P naught of A. This is a colligative property. So please note, if there is a relative, then only this is colligative, or else it's not a colligative property. So answer is option D. Then second question, 3 grams of urea is dissolved in 45 grams of water. 3 grams of urea is dissolved in, let me erase this. Yeah, 3 grams of urea is dissolved in 45 grams of water. The relative lowering in vapor pressure is. Yes, let's solve this. P naught of A minus P divided by P naught of A, they are asking. This is nothing but mole fraction of the solute, XB. Okay, so what is this? This is 3, mole fraction of solute is, mass of the solute is 3 grams and molar mass of the solute is 60, because molecular mass of urea is 60. So let me write the given data. Weight of the solute, that is 3 grams. Molar weight of the solute, that is 60 grams. Okay, 60. Then weight of the solvent Wa is 45. Molar mass of the solvent is 18. Okay, so now we are supposed to calculate NB. NB is equal to, we know that NB is equal to weight of the solute by molar weight of the solute. So here I can write it as NB divided by Na plus Nb, mole fraction. Fine. So simplify it further. Yes, which is equal to Wb by Mb whole divided by Wb by Mb plus Wa by Ma. Mass of the solute is 3 grams divided by molar mass of the solute is 60 divided by 3 grams divided by 60 plus weight of the solvent given is 45. So 45 divided by 18. Okay, so if you simplify this, 3 ones are 3 20s are, right? So here this goes with 18 ones are 18 2.5s are, because 18 fours are 18 fives are 90, so 2.5s are. So 20 plus 2.5 is okay, so 3 ones are 3 20s are again. So if you simplify this, you get 0.05 into 2 divided by 2.55 into 2, which is equal to 0.005. 0.02. You can just simplify it and take the answer. Okay. So molar mass of urea, sometimes it will be given, but you must be knowing for few compounds, not for all. Okay. Yes, so the answer for this question is, you just simplify it, you will get the answer. It is 0.02. The next, which of the following aqueous solution will exhibit higher boiling point? Okay. So which of the following will have higher boiling point? So when such questions are given, so we are speaking of elevation in boiling point, delta TB. As delta TB is more, the boiling point will be more. Elevation in the boiling point will be more for water. Okay. So when this TB is going to be more, this is directly proportional to number of particles. So you count the number of particles or number of moles of the particles in these cases. Urea is not undergoing any kind of dissociation. So number of moles is 0.01 moles only. I'm taking for 1 liter. Then coming to KNO3, 0.02 molar KNO3. Each KNO3 can undergo dissociation to give K plus plus NO3 minus. Means a single particle is dissociated into two particles. So if I take 0.01, it will be dissociated and it gives 0.02 moles. Right? Number of particles is double here. When you come to this, here this Na2SO4 will split into Na2SO4 will give 2Na plus SO4 2 minus. So the number of ions are 2 plus 1 3. So this gives 0.03 moles. Okay. And coming to this glucose, it doesn't undergo dissociation or association. So it is 0.015. So out of this third option has got more number of particles. So the elevation in boiling point is more. So this will have higher boiling point. Are you getting that? So answer is C. Okay, next. 5.5 milligrams of nitrogen gas dissolved in 180 grams of water at 273 Kelvin and 1 atmosphere pressure due to nitrogen gas. The mole fraction of nitrogen in 180 grams of water at 5 atmospheric nitrogen pressure is approximately. Okay. I'll use this annotation. It's better. Okay, check here. So what is being given? 5.5 milligrams of nitrogen gas. Mass of the nitrogen gas is given. So we know that pressure of a gas is equal to Kh into mole fraction of the gas. Right? This is according to Henry's law. So mole fraction of gas, you can they are given two different situations. One with 5.5 milligrams of nitrogen gas in 180 grams. Other one is mole fraction of nitrogen gas in 180 grams of water and 5 atmospheric pressure. They are asking us to calculate it. Okay. So here the 1 atmospheric pressure is given. So P1 by P2. We are going to take two situations. P1 by P2 is equal to mole fraction in the first case divided by mole fraction in the second case. So mole fraction in the first case is, how do we calculate it? Yes. So mole fraction is nothing but number of moles of gas divided by number of moles of gas plus number of moles of water, whole divided by mole fraction of second one. Okay. Are you getting that? Okay. So therefore, what we have now? So we have P1 by P2 is equal to number of moles of one, gas N2 divided by number of moles of N2 plus number of moles of H2O divided by mole fraction of second one. So which is equal to milligrams they have given 5.5 into 10 power minus 3 divided by 28 molar mass of nitrogen. Similarly, 5.5 into 10 power minus 3 divided by 28 plus mass of water is given 180 grams. So 180 divided by molar mass of water is 18 whole divided by mole fraction of the solute. P1 is given and P2 is given, right? P1 is 1 atmosphere, P2 is 5 atmosphere. Therefore, 1 by 5 is equal to, so if you just simplify this, so I think you can neglect this 5.5 into 10 power minus 3 by 28. So you get nearly about x2. Just simplify this. I'm running short of time. I'm just showing you the method. You get mole fraction of the solute is equal to 1 into 10 power minus 4. You can check it. Just simplify this number, you will get the answer. Okay, is that clear for everybody? Yes, then let's go with this question number 5. Just give me 1 minute. Yes, question number 5. Yes, when it comes to question number 5, check here. A solution of 1.25 grams of P in 50 grams of water lowers the freezing point by 0.3 degrees centigrade. Molar mass of P is 94. Kf of water is 1.86 Kelvin kg per mole. The degree of association of P is. See, elevation in boiling point delta TB they have given. It is about depression in the freezing point delta TF is equal to Kf into WB into 1000 divided by MB into WA. Okay, so you're supposed to calculate the delta TF, and here you can introduce the Van 't Hoff factor I here itself. Solve for I will be equal to delta TF into MB into WA whole divided by Kf into WB into 1000. Okay, therefore I is equal to delta TF is, the delta TF value is given, depression in the freezing point. So the depression in the freezing point is 0.3 degree. So take 0.3 here into MB, molar mass of the solvent. That is molar mass of the solvent is, it's a aqueous solution. So 18, solute. Molar mass of the solute is given there. It is 94. Yes, it's 94 into mass of the solvent. Mass of the solvent is given as 50 grams. So 50 divided by Kf is 1.86. Check here, Kf is 1.86 into mass of the solute is 1.25 grams. 1.25 into 1000. If you simplify this, yes, if you simplify this, I will come out to be 0.60. Okay, but we are asked to calculate the degree of association. In the beginning, I have given you the formula for degree of association. Alpha is equal to I minus 1 divided by 1 by n minus 1. So here this P is getting associated, right? P is becoming P2. Therefore, N, you are supposed to take how many molecules are becoming, how many molecules are getting associated. Therefore, I is equal to 0.6 minus 1 divided by 1 by 2 minus 1. So it is 0 minus 0.4 divided by minus 0.5. Minus minus will be cancelled. You get 8. 0.8 as the answer. 0.8 is the dissociation, means how many percent it will be dissociated. It is 80%. Now, general one, you need to know the molar mass of the compounds. Usually they give the values if it is so complicated. Yes, that's regarding question number 5. So please make use of these formulas. This N is the for an ideal binary liquid mixture. Yeah, binary liquid mixture. It's an ideal mixture. Delta S is going to be greater than 0 and delta G is going to be less than 0. I have already given you the conditions, right? Okay, fine.
Excuse me, sir. I think we have to stop, sir, because they have break hour now
Okay,
from
okay, fine.
10 to 10:30.
So someone wanted to take the screenshot. What shall we do?
Sir, I think we'll just present the slides and they can take screenshots and keep.
Okay, fine, fine. Yes.
Students, please take screenshots of the slides for your reference.
Yeah, this is the first slide. This is the second one. This is the third. Okay, next liquid in liquid. Yeah, someone is asking me, sir, how N is equal to 2 in that problem? Because P is getting associated to form a dimer. See, the number of how many number of molecules are getting associated, that is the N value, and number of particles dissociated, number of particles available on dissociation, that is N value for dissociation. Okay. Yes, this is the next slide. And this is the last one. So let me write here where N is equal to number of particles obtained on dissociation. N is number of particles associated. For example, A is combining with one more A to get A2. In such case, N is equal to 2. If A plus A plus A gives A3, N is equal to 3. There is something like ABC. If it splits to A plus BC, N is equal to 2. If ABC splits as A plus B plus C, N is equal to 3. That is dissociation and association. Okay. So thank you, everyone. Hope
Thank
you
you,
had
sir.
a nice time. Thank you very
Thank
much,
you, sir.
sir.
Thank you so much, sir, for joining. Students, now you have your break hour. So we'll again join at be on this same link only. You can join again from this link. You have biology hour from 10:30 till 12:30. So have your break, have your breakfast, and join again. Students, you can download your notes from the given link on the background, and also you have been provided with a link from where you can see your recorded sessions. Also, you have been provided with the helpline number and the email ID. If you have any queries, any feedbacks, any suggestions, or you want any, if you are not able to log in and if you are not able to download the notes, you can just contact there and get it resolved.
Bengaluru, that counts as the third top startup city across the globe, opens up a new and exciting opportunity for all innovators to come on board at the Dayananda Sagar University. Founded by late Sri R. Dayananda Sagar and late Dr. Chandrama Sagar, Dayananda Sagar Institutions is into education and healthcare for over 6 decades. DSI is today considered a center of excellence in producing students with exceptional academic skills and leadership qualities. DSI is now headed by Dr. D. Hemachandra Sagar and Dr. D. Premachandra Sagar. This leadership has successfully managed and excelled in ensuring excellence in all of its offerings. This great foundation ensured DSI to be invited by the Karnataka state government to set up a private university in the state. DSU could be among the very few campuses in the country to have a well-planned startup village that houses innovation labs supported by industry leaders. DSU provides a platform to visionaries and inventors to experiment their ideas. Globally reputed MNCs that include Autodesk, Bosch Etas, IBM, GE, VMware, NVIDIA, and Boston, Bosch Rexroth, Dassault Systems are now part of the DSU initiatives. These companies have invested vast resources to create a one-of-its-kind facility to be used by the community. Joining this great movement is the support from industry bodies, Indian Electronics and Semiconductors Association, Manufacturers Association of India, and Indian Institute of Science in Bengaluru. The Startup Village will now receive guidance from Arizona State University, Rochester Institute of Technology, and Illinois Institute of Technology, Chicago. With a reputation for innovation, are strong backers of the DSU initiatives. Distinguished individuals from industry, academics, research, government are lined up to mentor each of the entrepreneurial
ಸರ್ ಲಿಂಕ್ ಕಳಿಸಿದ್ದಾರೆ ಬೆಳಗ್ಗೆ
meet with success.
ಅದು ಹೋದ್ರೆ
Advertisement ಬರುತ್ತೆ. Costing and taxation specialists, company secretaries, procurement engineers,
10:30 exact ಆಗಿ
packaging specialists, logistics experts is one more feature of the DSU campus. Every year, groups of individuals enter the DSU portals with a burning passion.
Thank you, sir. Okay, sir. Right. Okay, sir.
To achieve. With the combined support and resources at their command, They are now sure to walk out of the DSU campus as owners of the companies enlisted on the National Stock Exchange and a university degree. The ecosystem created by DSU can now accommodate 300 enterprises and welcomes the community to take advantage of this great option and work towards making India a strong manufacturing nation. For passionate and innovative youth, Bengaluru is the place to be. And presenting
Dayanand Sagar University. Live the dream.
Good morning, ma'am. Hello. Good morning, ma'am. Good morning, ma'am.
Good morning, sir.
Ma'am, we'll start in some time. Let's all attendees join once again.
Yeah, okay.
Okay, ma'am. Dear attendees, please don't raise your hand every time because it may interrupt teachers. So please, if you have any queries or any doubts, please put it in the question and answer box. Ma'am, I think we should start now, ma'am.
Yeah. Sir, my voice is audible, right?
Yeah, ma'am, it's audible, ma'am.
Yeah.
Ma'am, we'll answer the questions raised by students after, like at the end of the session, or in between we'll answer the questions.
Sir, at the end, I'll give 5 minutes for the question and answers, right?
Okay, ma'am.
Yeah. Good morning, students. We'll start with the today's class, that is bio class. All of you here, can you hear my voice, right?
Yeah, ma'am. Yeah, ma'am. Your voice is audible. They can unmute themselves as well.
Yeah, okay. Fine. I'm starting just share screen. Sir, I can't share my screen.
Just a minute, ma'am.
Yeah.
Yeah, ma'am. Now you can.
Yes. Yes, I think screen is visible, right?
Yes, ma'am. It's visible, ma'am.
Yes. Students will start with this today's chapter, that is today's topic, that is reproduction in organisms and sexual reproduction in flowering plants. I think you all know about reproduction. What do you mean by the reproduction? The reproduction is the basic thing actually. It is what it is considered as what a biological process in which organisms gives rise to young ones that similar to their parents. that is all organisms, even it may be a plant or it may be an animal, all organisms have ability to reproduce. I think you're all studied about living organisms. Which are the organisms are considered as living? The organisms which will be having characteristics like sense and ability to reproduce. They must show growth and development, right? So all these things, main concept to consider living organisms is this reproduction. This reproduction process is considered as what? Main concept of living organism. That is, a living organism must be able to reproduce. That is the main criteria to consider organism as a living or non-living. Even students listen, even non-living things also show some growth and development, like mountains may show growth, like Himalayan height will be increasing year by year, like this. All the living organisms, non-living organisms also show some growth and development, but those are not considered as reproduction. Only the development, only the growth. See, that's why final criteria to consider living organism as a living organism is, along with this reproduction, sense consciousness is considered as a main criteria. In this class, we are going to study about what are the types of reproduction and what are the things involved in reproduction. See, I think you all know about the types of reproduction. See here, here there are two types of reproduction, that is asexual reproduction and sexual reproduction, right? So this asexual reproduction, classification of this reproduction, that is asexual and sexual, based on the number of parents. Here in asexual reproduction, only one organism or one individual will be involved in the process of reproduction. Here in the sexual reproduction, there is involvement of two living organisms or two individuals belongs to a same species or a different species. That is a different thing that involved in sexual reproduction. First, we shall pass on to this asexual reproduction. Asexual reproduction, what do you mean by this asexual reproduction? As I told, here only one parent is involved, that is only single organism. I think you all know this is what amoeba, a unicellular organism or a microorganism. So many microorganisms are there. In that, we consider amoeba as a typical example for unicellular prokaryotic organisms. You know about prokaryotic organisms as well as eukaryotic organisms. Prokaryotic organisms are having a primitive nucleus which doesn't have a prominent nucleus. Eukaryotic organisms are having a prominent nucleus. Those are comes in higher organisms, multicellular organisms, eukaryotic organisms. See, here in amoeba, there is no involvement of two individuals to produce two individuals. See, here is only amoeba is going to reproduce two individuals. That is the thing, involvement of only one parent in asexual reproduction. Asexual reproduction happens in both male and female organisms. Asexual reproduction happens in both plants as well as animals, right? See, examples for organisms, that is typical example is amoeba, euglena, paramecium, penicillium. All these things involved in the types of, there are so many types of asexual reproduction are there. Then sexual reproduction involves two individuals for the reproduction process. See, here what happens in this asexual reproduction is, before going to the actual thing of this reproduction, usually the organisms have a different lifespan, I think. See, the life of an organism, see, from birth to death. From birth to death, life of an organism is considered as what? Lifespan. In this lifespan, see here. Yes, birth to death. This is considered as what? Lifespan. This lifespan can be divisible into three categories, that is juvenile phase, maturation phase, as well as aging or senescence. See, the reproduction process happens in this maturation phase only. Maturation phase is nothing but our ability to reproduce. The organisms which are having ability to reproduce are comes under this maturation phase. See, here in the asexual reproduction, see, different organisms will be having different lifespans. That is the time from birth to the organism which will be having a time from birth to death. That that duration is called as what? Lifespan. Different organisms will be having different lifespans. So, see, yes, in this maturation phase, what happened? The organisms are able to reproduce. Organisms are able to reproduce by the process called asexual reproduction. Typical type of reproduction is what? Asexual reproduction. See, without the formation of another definition, proper definition for this asexual reproduction is about without formation and fusion of gametes, the organisms are going to reproduce. See, usually in the sexual reproduction, there is a formation and fusion of gametes will be taken place, that is sexually reproducing organisms. In sexually reproducing organisms, we also see that is a sexual dimorphism. What do you mean by this sexual dimorphism? Is by appearance only we are going to identify whether it is a male individual or it is a female individual. That comes under this sexual reproduction. But in the asexual reproduction, what happens? There is no formation and fusion of gametes takes place. That is asexual reproduction. What are the types of asexual reproduction? There are so many types of asexual reproduction are present. I think you all know about asexual reproduction. Here there is no formation and fusion of gametes will take place. Majority of the asexual reproducing organisms are prokaryotic organisms. See, here so many types of asexual reproduction is present. That is first and foremost thing is, see, here you can see the criteria. Asexual reproduction can be classified into fission, spore formation, regeneration, budding and vegetative propagation. All these things can be come under the asexual reproduction. One more thing is there. In vegetative propagation, there are types will be there that we will see later. See, in this types of fission, there are so many types of two types of fission will be there. That is two types of fission will be there. That is the binary fission as well as multiple fission. Fission having two types, that is binary as well as multiple. Binary fission as well as multiple fission will be there. So, but what do you mean by fission? See, fission is a common cell division, normal cell division. Mitotic cell division takes place in the unicellular microscopic organisms like amoeba, euglena, paramecium, all these things, even cratium, all these things, all these organisms undergo the normal process of this fission. See, here there is a formation of binary fission as well as multiple fission. Usually binary fission means division of a cell, division of a single cell into two. See, here you can see the splitting of one cell into two cells. So this happens in amoeba, paramecium, euglena. And here there is a formation of multiple fission. Multiple fission is also there. Usually multiple fission means here there is no, what happens in multiple fission, consider if this is a cell and this is a nucleus which is present inside the cell. And what happens during the unfavorable conditions, you all know about the favorable conditions and non-favorable conditions for the growth and development, reproduction also. All the things like temperature, osmotic concentration, all these things have to be in a proper, that is optimum for the process of reproduction. if there is a case of what unfavorable condition, what happened, the organisms undergo the process of this multiple fission. Here there is no division of cell wall taken place. The cytokinesis, see, cell division, usually cell division happens by a cell cycle. You know that is a synthetic phase, G phase, G2 phase, metaphase, that is prophase, metaphase, anaphase, telophase, and cytokinesis. Usually karyokinesis is a division of what? Nucleus. Karyokinesis is a division of nucleus, and cytokinesis is a division of what? Cytokinesis is a division of cytoplasm. Here in the cell, you know that there is a nucleus as well as cytoplasm. What happens in the cell division? First, the division of nucleus takes place. See here in this diagram also, in this diagram also you are able to see this thing, that is, see here, one cell, first a nucleus undergone the division, and afterwards the cytoplasm will divided. So division of this nucleus is nothing but karyokinesis, and division of the cytoplasm is nothing but karyokinesis. So usually a normal cell division, mitotic cell division, takes place in the fission. Multiple fission in the sense only the multiple nuclear division happens in some organisms. That leads to what? Multiple division. So multiple division happens in Plasmodium, Chlamydomonas, and some algae. The multiple fission will be taken place. So this is about fission. This is the first type of asexual reproduction, happens in unicellular organisms. Asexual reproduction means there is no formation and fusion of gametes will take in place. Only cell division, simple cell division, or other types of reproductive structures are there. So this is about fission. Next comes to this spore formation. This spore formation, there are some types of spores will be produced in the organisms, like this Chlamydomonas. Here you can see the Chlamydomonas, and this is the structure of what? Penicillium. Here the spores are what? Conidiospores. There are so many types of spores will be present, that is yes, there are different types of spores are present. See here in Chlamydomonas, you are going to see the spores with flagella. I think you are able to see this diagram. Here the flagella will be present. So this flagellated spores are called as what? The zoospores. There are so many types of spores will be present. That is, in Chlamydomonas, there is a spore will be having a flagella. That is, flagella is a locomotory structure helpful in the movement of what? The spores. So then in Penicillium, there is a non-motile spores are produced. See here what happens, the spores are produced. See in this diagram, spores are produced within the cell itself. So this condition is called as what? Endogenous production of spores. See here in the Penicillium, what happens? The spores are produced exogenously, that is outside the cell, outside the body of an organism, spores are going to produce. That condition is called as what? Exogenous spore production. Yes, example for this is what? Penicillium, and the spores which are produced by this Penicillium are called as what? This structure which is going to produce, which is going to bear the spores, is called as what? Conidiophore. The spores which is going to, the spores which are produced. See here, this structure. What is this structure? This structure is considered as what? Conidiophore. This conidiophores are bearing a spores called conidia. Here the spores which are produced by Penicillium are called as what? Conidia. See this here, the spores are produced exogenously. In the Chlamydomonas, spores are going to produce endogenously. And Chlamydospores, one more types of spores are produced. So many types of spores are there. That is the zoospores, chlamydospores, aplanospores, basidiospores, even gemmules. All these comes under the spores itself, spore formation itself. And this basidiospores, among all these spores, aplanospores and zoospores, which are helpful in the asexual reproduction types, and conidia is also helpful in the asexual reproduction types. See, this is about what? A spore formation in organisms. Yes. Next part is what? Next type is regeneration. Among this, next is regeneration. What do you mean by this regeneration? In the sense, the organisms, in some organisms, what happen? If there is a breakage in any part, see, example for this is what? Planaria. If there is any accident happens to this organism, the body parts cut into several parts. Like, see, here you can see the one planaria can be break down into 7 parts. Each 7 part will grow as a 7 individual. So that process is called as what? Regeneration. This is also a type of what? Asexual reproduction, right? So next type is what? A budding. Here also, it is also a type of what? Asexual reproduction. Here, budding example, typical example for budding is hydra. See, here in the stem cells, this is the structure of hydra. It will be having a mouth, tentacles, stem region, as well as hold fast, right? See, here in the stem region, what happens? There is a presence of cells which will be able to produce a bud-like structure. So these buds are attached to this parental organism until they get ability to get their nutrition. After that, what happens? They will be pinched off from the parental plant and grown as a independent individual. Not only in the hydra budding happens in yeasts also. In yeast cells also budding happen. So this types of budding, 2 types of budding will be there, as spores, endogenous spores as well as exogenous spores. In budding also 2 types of budding will be there, that is exogenous spores as well as endogenous spores. See, in hydra, see here you can see the budding will be appear on the surface of the body of organism, right? So endogenous or internal budding will be happen in sponges, that is example spongilla, and freshwater sponge like spongilla, as well as marine water sponge like scion. These will be having a ability to produce a spores called gemmules. What happen? On germination, each gemmule gives rise to a offspring. Those are going to be considered as a internal birds, right? This type of budding, this type of internal budding shown by sponges are called as what? Internal budding or endogenous budding. So these are the types of buddings. Buddings shown in budding type of reproduction shown by a hydra, as well as this yeast, as well as spongilla and scion, right? So this one more thing is that these are the types of what? Asexual reproduction. One more type, purely meant for plant species. See, here you can see even plant species, fungi, organism, animals, microorganisms, all these things are following asexual type of reproduction by different modes, like fission, binary fission, spore formation, regeneration, budding, as well as here the vegetative plant vegetative propagation, that is purely meant for the plants, purely meant for plants. Then what do you mean by this vegetative propagation? Vegetative propagation is nothing but regeneration or reformation of individuals by vegetative parts, Yes, by vegetative parts. See, here there are types of what? Vegetative propagation. here what happens in this vegetative propagation, many plant species are going to reproduce without formation of gametes, male gamete and female gamete. In plants, the male gamete is considered as what, andrecium, and female reproductive structure is considered as what, gynaecium. That and also anthridiophore, archegoniophore, different plant species will be having, different plant families and kingdoms will be having male reproductive structure as well as female reproductive structure. Other than that, the plants are going to reproduce asexually by vegetative propagation method. What are this vegetative propagation? In the sense, the plants which will be having some parts like root tip, shoot tip, the parts which are going to propagate, the parts of the plant which are going to propagate the whole plant, those are considered as what, vegetative propagules. So what is the importance of this vegetative propagation other than sexual reproduction happens in plants? In the sense, now see, usually we are going to use to grow some seedless fruits like banana, rose, grapes, oranges. All these things can be propagated through this vegetative propagation methods. See, here in this vegetative propagation, there are two types will be there, that is natural vegetative propagation as well as artificial vegetative propagation. Yes, natural vegetative propagation will be made by naturally by plants like by suckers, rhizomes. See here, rhizome of a ginger, suckers, as well as rhizomes, bulbs, tubers. See here, tubers of a potato, and bulbs of agave, as well as all these things, bulb of onions, as well as bulb of onions, bulb of agaves. All these things will be propagated naturally. And there are stems like underground stems. See this rhizome, ginger, as well as potato, all this comes under underground vegetative propagation. And creeping stems also there, that is runners. See, this is what chrysanthemum plant. This plant will be, the stem is creeping. Usually the stem is creeping. At the nodal regions, what happened? The adventitious roots will be produced. So runners, stolons, suckers, offsets, all these things are what? Naturally creeping stem vegetative propagations. See, vegetative propagation also happen by roots. Like for example, asparagus, dahlia, tinospora, all these things, the vegetative propagation by roots. As I told, the parts of the plant, it may be root, or it may be shoot, or it may be leaf, or it may be a bud part, whatever it may be, the parts of a plant which will be having capacity to propagate their parental plant, those are called as what? Vegetative propagules. See here, there are so many types of vegetative propagules will be there. See, as I told, propagation by underground stem will be happen, propagation by roots will be happen, and vegetative propagation by leaves will be happen through that bryophyllum. That is bryophyllum. See here, you can see this is bryophyllum. Here there is a presence of what? Nodal regions, that is notch region. In that notch region, what happened? The buds will be formed, the plantlets will be formed. Each plantlet pinched off from the parental plant. See, in this leaf, you can see the plantlets will be fallen off from the parental plant. So this is by the propagation by leaves. Is like this, the roots will be produced at the nodal regions of the leaves. Yes, and also vegetative propagation happens by reproductive parts like in allium, sepa, and agave, bulbils are considered as what? Vegetative propagative parts. And artificial vegetative propagation is also there, that is by cutting, layering, grafting, all these things are what? Artificial vegetative propagations. What happens in cutting? Cutting is the process of artificial vegetative propagation. Normal cutting of a stem, about 20 to 30 centimeter long pieces of a stem have to be cut. This propagation will be happen in grapes, sugarcane, rose, bougainvillea, all these plants are propagated through a normal cutting process. That is, even hibiscus plants are propagated through this normal cutting process. And one more artificial type of vegetative propagation is there, that is layering. See, layering is nothing but layering is somewhat different from cutting. See, here in the development of adventitious roots is induced before the plant can be detached from the parental plant. So that is layering type of vegetative propagation. See, in chrysanthemum as well as jasmine and all these things, we have mound layering as well as air layering. What we have to do in layering is, we have to scrape the part, we have to scrape the epidermal part of the stem, and we have to add a nutrition to that and allow the plant for a growth that is adventitious root, allow the plant branch to the growth of adventitious roots. Then air layering will be there. And one more thing in this vegetative propagation, that is artificial vegetative propagation, is a grafting. Grafting is a type of what? Another artificial method of vegetative propagation. Here in the grafting, what happens? See, one stem is there, and we have to cut this stem like this, V shape. This is called stalk. This is called stalk. STOCK, and we have to introduce another plant stem into this stalk, that is called as what? Scion. This has to be cut in a shape of arrow like this. And this is called as what? Scion. Like this, the plants will be propagated by the process of what? Grafting. There are so many types of grafting will be there, that is tongue grafting will be there. See, as I told, this is what this type of grafting is, wedge grafting. This is what wedge grafting. And crown grafting will be there. This crown grafting is helpful in reforestation. This crown grafting will be helpful in reforestation, that is boring in a stem of a large trees and introducing a small plantlets into that holes of a large trees, and this grafting, that is called as what? Crown grafting, helpful in what? The process of reforestation. All these types will be helpful in the vegetative propagation. One more thing will be there in artificial propagation, that is micro propagation. Micro propagation, what do you mean by this? Micro propagation is by using the tissues of a plant. By using any one tissue of a plant, we are going to raise the whole plant. That is called as what? Micro propagation. Tissue culture process, by using well sterilized conditions, well equipped laboratories, we are going to raise the plantlets by using only one tissue. We are going to remove the meristem regions. See, meristem regions are present in apical part of a plant. Apical part of a plant will be having what? Meristems. We are going to extract this meristem, and we are going to introduce this meristem into a culture media, which will be having a nutrient media called agar-agar. That agar-agar is extracted from a red algae like Giladium and Gracilaria. This Giladium and Gracilaria are the agar-agar, that nutrient media extracted from this red algae, will be used for culturing, will be used as culturing media for culturing many organisms, even microorganisms, and in the tissue culture process as well as micro propagation. Excuse me. What happens? This if we introduce this micro, that is meristem, into this culture media, what happens? There is a growth in this meristem will be taken place. There is we can't differentiate the cells in this condition. So this condition is called as what? Callus. Yes, the undifferentiated mass of cells which are produced by the meristem are called as what? Callus, which will be later differentiated to produce a large number of plantlets. This callus in future going to give rise to a large number of plantlets. Those plantlets are separated and transferred to a nursery plates. This is how we are going to grow large number of plantlets in a shorter period of time. So this is very important. In this micro propagation, we are able to produce a disease resistant varieties, because this meristem region, what is present in this plant, in the plant region, in the plant apical part, whatever it may be, what plant it may be, see here in this bryophyllum, in this apical part, this part, the meristem region, and also this is this plant, whatever it may be, apical part, there is a presence of what? Meristems. In that meristem, there are three types of meristems will be there. That is apical meristem, lateral meristem, and intercalary meristems. Apical meristems are present at the apical part of the plants, and lateral meristems present at the lateral side of the stem regions, and intercalary meristems are present at the nodal regions of a stem. See, these are able to contribute in the height growth and development of plants, because this meristems having a rapid cell division capacity, and these are disease free. These are considered as what? Disease-free tissues. That's why in micropropagation, we are going to use this meristems only. That's why we are able to produce disease-resistant varieties. So this is all about the reproduction, asexual reproduction. How many types of asexual reproduction are there? That is fission, spore formation, regeneration, budding, and vegetative propagation will be there. See, in vegetative propagation, there are natural methods as well as artificial methods are present. This is about asexual reproduction. This asexual reproduction is very important in maintaining a pure line. See, in asexual reproduction, we are going to get clone copies, exactly the offsprings which are look exactly like a parent. See here, this is planaria, which look exactly like its parent. This is amoeba, which looks exactly like amoeba. Like this, we are going to get clone copies of parental offsprings. We are not going to get any variations in asexual type of reproduction. Why? Because there is no recombination of genes or recombination of chromosomes will be taken place in asexual reproduction. That's why in asexual reproduction, there is no variations will be taken place. We are going to get exactly clone copies of parents in asexual reproduction. This is all about what? Asexual reproduction. Yes. Now we shall pass on to the sexual reproduction. Now we shall pass on to sexual reproduction. Here, as the definition says, the sexual reproduction, the formation and fusion of gametes will be taken place in this sexual reproduction. Formation and fusion of gametes will be taken place in this sexual reproduction. See, what do you mean by the formation and fusion? In which organism the sexual reproduction is going to happen? In this sense, it will be happen in both plants as well as animals. Both plants and animals are going to follow the sexual mode of reproduction. What do you mean by the sexual reproduction? See, here there is a formation and fusion of gametes will be taken place. Students, I think we all know about the types of cell division. How many types of cell division are present? 2 types. Which are those? Mitosis as well as meiosis, right? So these are two types of cell division. In the body of an organism, there are two types of cells are present. What are those? Somatic cells as well as germ cells. In somatic cells, mitosis division will take place. In meiosis will be happening in germ cells. This mitosis cell division is considered as equational cell division. This meiotic cell division is considered as reductional cell division. What happens in this meiosis is, one cell is present, it will be having two n number of chromosomes, that is diploid number of chromosomes. This cell, if this cell undergo the process of this meiosis, what happen? It will be resulting two haploid cells. The cell which is undergone the process of meiosis will give rise to two haploid. That is, here the chromosome number will be reduced. That's why here it is called as what? Reductional division. But what happens in mitosis? So what happens in this mitosis? Mitosis will be if there is a presence of diploid number of chromosomes in a cell. If it is undergo what? Mitosis division, it will be results in two cells, but those two cells will carry exactly same chromosomal number of the parent. So this is the main difference between what? This is sexual reproduction. There is a formation and fusion of gametes will be taken place. That is formation, and after formation, this formation and fusion of gametes, that is the definition of sexual reproduction, will be happen in three main criteria. That is pre-fertilization events, fertilization events, as well as post-fertilization events. That is the definition. What is that? Pre-fertilization events. We talk about this pre-fertilization events. This pre-fertilization events are involving the process of what? Gametogenesis. That is what do you mean by this? Gametogenesis is the formation of gametes. Formation of gametes is nothing but the gametogenesis. This pre-fertilization events will be, yes, this pre-fertilization events consists of what? Gametogenesis. That is, formation of gametes is nothing but the process of formation of gametes is nothing but gametogenesis. This pre-fertilization events, that is the whole maturation phase or aged phase of an organism, will be having all these three stages: pre-fertilization, fertilization, and post-fertilization event. This pre-fertilization events in human beings happens at puberty. In plants happens at the age of what? Maturation, right? The gametogenesis usually refers to the formation of types of gametes. In males, there is a formation of what? Antherozooids as well as antherozooids are formed. In females, ovum are going to be produced. See, on the basis of morphology, what happens? On the basis of morphology, on the basis of physical appearance, there are two types of gametes, that is homogametes and heterogametes. What do you mean by this? Homogametes is, this homogametes is there is a formation of two gametes. Those are completely similar in physical appearance. Those are called as what? Homogametes. And what about this heterogametes is, example for this homogamete is cladophora is going to produce two gametes. Those are completely similar to each other. And what about this heterogametes in fucus? Example for this heterogamete is fucus. This fucus is going to produce two types of gametes, that is dissimilar gametes. That is dissimilar gametes. In heterogametes, there are types will be there. That is, oogamous type of gametes are going to produce, and heterotype of gametes are going to produce. That is, one gamete is larger in size and one gamete is smaller in size. That is heterogamete. And this pre-fertilization event also consider gamete transfer. That is production of gametes, that is formation of gametes, and transfer of gametes into the site of what? Fertilization. That events involved in this, the pre-fertilization event. That process happens in this pre-fertilization events. See, in plants, how this gametes are going to transfer, in the sense by the process of pollination. What do you mean by pollination? What are the types of pollination? That we will discuss little bit later. Then we shall pass on to the next event of sexual reproduction, that is fertilization. What happens in this fertilization is the fusion of male and female gamete to produce a diploid gamete. See here, here in the formation, in the gametogenesis, what happened? This cell undergo the process of meiosis, are going to produce only haploid gametes. By the fusion of these two haploid gametes, if this gamete is going to fuse with the another haploid gamete, what happened? This will be resulting in diploid gamete. So this is the diploid gamete, that is the result of sexual reproduction. See, this process, the fusion of haploid carrying gametes, is nothing but fertilization. Fusion of haploid carrying gametes fused together, that process is called as what? Fertilization. In fertilization, there are two types will be there, that is external fertilization as well as internal fertilization. What do you mean by this external fertilization? This happens in fishes as well as amphibians like frog. There is a liberation, that is a releasing of sperms and ovum into sperm is a male reproductive gamete and ovum is a female gamete. So releasing of those male gamete as well as female gamete into an external environment, like usually this external fertilization happens in water media itself. So that's why frog needs water to complete its life cycle. There what happens, the fusion of gametes will take place. Then that is called as the fertilization of male and female gamete happen outside the body of an organism is called as what? External fertilization. What about this internal fertilization? Fertilization happens within the body, female individual's reproductive structure. That is called as what? Internal fertilization. That is the fusion of male and female gamete within the reproductive system of a female individual. That is nothing but internal fertilization. Usually this external fertilization leads to indirect development of an organism. That's why we are going to see a larval stages in the external fertilization. I think you're all aware about the tadpole larva of frog. That is a larval stage of frog. Because of what? Indirect development. If there is a presence of intermediate stage between fertilization and the actual organism, that is called as what? Larval stage. That larval stage is present in frog and externally fertilizing, internally developing organisms. And internal fertilization leads to, see, in this external fertilization there is no assurance of proper fertilization, but in internal fertilization there is assurance of what? Proper fertilization. This internal fertilization assures the fertilization, because fertilization, fusion of male and female gamete happen within the body of an organism. That's why internal fertilization is more assured than external fertilization. So this is the second event of what? Sexual reproduction. Then comes to this post.
Hello, ma'am. Ravi Shankar here. ಸೈನಪ್ಸಿಸ್ ಬ್ರೀಫ್ ಆಗಿ ಸಾಕು, ಅವ್ರಿಗೆ ಮಕ್ಕಳು ಓದ್ಕೊಂಡ್ ಬಂದಿರ್ತಾರೆ.
ಓಕೆ,
ನೀವು ಕ್ವಶನ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡಿ, ಯಾಕೆ ನಿಮ್ಗೆ ಇನ್ನು 1 hour ಸಿಗುತ್ತೆ ಅಷ್ಟೇ. ಓಕೆ.
So this post-fertilization events will be having formation of, that is the further development of what? Fertilized egg, that is formation of zygote, that followed by embryogenesis. Ovipary in the sense laying egg organisms, and vivipary is nothing but directly giving birth to young ones. So reproductive organs are present in plants as well as animals. Unisexual organisms, that is single individual will be having single reproductive structure. Bisexual organisms, hermaphrodites, that is both male and female reproductive structures present in same organisms. See, this is how the sexual reproduction happens in flowering plants. Flowering plants will be having both the male and female reproductive structure in a same flower or in a same plant. Yes, so this pollination, see, for microsporogenesis leads to formation of what? Anther, and megasporogenesis leads to the formation of what? Egg or ovule. Then this flower will be having a whorls. I think you're all aware about that. And this leads to what? The fusion of this anther and egg leads to what? Fertilization. Here in flowering plants, there is a formation. There is double fertilization will be there by the process of what? Pollination. Types of pollination, like so many types of pollination will be there. This will I'll discuss in questions itself. All these things will be there in questions. Yes, directly we will pass on to the questions. See here, which of the following statement is correct? They are asking. First option is, all the individuals of a species have exactly the same lifespan. Smaller organisms always have shorter lifespan, and vice versa. Lifespan of an organism is the time period from its birth to its natural death. No organisms may have a lifespan of several hundred years. So among all these things, we have to choose which is a proper right statement. To answer this question, we have to know about the lifespan of an organism, right? See, different organisms will be having lifespan of an organism is the time period from its birth to death, right? All individuals are not going to have exactly the same lifespan. Here you can see different organisms will be having different lifespans. Lifespan means the duration from birth to death is nothing but lifespan, right? Smaller organisms will always have shorter lifespan, and vice versa. No, it is not a thing. The organism's lifespan, it doesn't depends on the size of an organism. So right answer for this question is option C. Right answer for this question is option C. Yes. So second question. Wait for a while. Yes. Among which of the following plants vegetative propagation occurs by adventitious birds? They are asking. See, first is this is what. First option A is what? Rhizome. Option B is what? Bryophyllum, and option C is the offset, that is Eichhornia. None of these. Among all these things, see here in the bryophyllum, in this bryophyllum only, we are going to see the adventitious birds that are called as what? Leaf birds. These are what? Adventitious birds. So right answer for this question is option B. Option B is the right answer. Yes. See, this is how the bryophyllum buds will be there. These are what? Adventitious buds. Okay. Then single-celled animals are said to be immortal because they grow indefinitely in size. They can tolerate any degree of changes in the temperature, change in the temperature. They can reproduce through their lifespan. They continue to live as their daughter cells. Among these things, which is a proper answer, see in unicellular organisms, what happen? Unicellular organisms, what happens? See, this is a parental organism. It divides and it will be live as a daughter cell. It will be, they will be continued to believe as a daughter cell. It is also a part of this organism. So answer for this question is option D. Option D is the right answer for this. Option D is the right answer for this. This is how. Why? Because this is how. Here the parental offspring is what? Continue to live as their daughter cells. Yes. Among these, select the option which arranges the given organisms in the ascending order of their lifespan. To answer this, we have to see again the lifespans of what? Organisms. They are asking in ascending order. That's why option is parrot, crow, butterfly, banyan tree. Banyan tree will be having more life. Yes, butterfly, crow, parrot, crocodile, fruit fly, crocodile, parrot, banyan tree, parrot, tortoise, dog, crow. See here in this picture, you are able to identify. You are able to know the lifespans, different lifespans of organisms. According to this, we are going to arrange the organisms in the ascending order. The option is C, that is fruit fly. Fruit fly will be having 2 weeks of lifespan, and crocodile will be having crocodile will be having 60 years of lifespan, and parrot will be having 140 years of lifespan, and banyan tree will be having 200 to 300 years of lifespan. That's why the answer is option C. Answer is option C. C is the right answer for this. And yes, the interspecific crosses mostly produce sterile hybrids. Such crosses are not favored by nature because their high frequency may be. See, what do you mean by this interspecific crosses? Interspecific crosses is nothing but the crossing over between non-species, out species. That is here. You can see here in the diagram, in the picture, that is, here is a combination of what? Lion and tiger. Liger is a crossing between lion and tiger, and mule is the crossing between horse and donkey, and jaglion is the crossbreed between jaguar and lion, and zonky is a crossbreed between what? Zebra and donkey. So like all these organisms are not able to reproduce. These crossbreed organisms are sterile hybrids. So that's why produce variation in organisms affect continuity of the species on the earth. Because why these organisms are not because these organisms are not able to continue their life. These are what? Sterile hybrids. Decrease the availability of food and other resources. No, this is not going to happen. And produce new species. These are not going to produce new species because these are what? Sterile. So this affect the continuity of the life on the earth because this organisms are sterile. That's why these are going to affect the continuity of the species on the earth. So we shall pass on to the next question. Study the given figures representing the process of binary fission in amoeba. See, in this figure, we have to choose what are the events happen first. Okay. See here, what are the events happens first? See, this is what a parental amoeba, it will be having a nucleus, cytoplasm, and vacuoles are going to present. See, then what happens? Elongation of nucleus, that is the division of nucleus taken place. Then what happens? Division of nucleus and cytoplasm will take place. That leads to what? Two daughter cells. So which is that option we have to select here? First is what? This picture has to be in a first position, that is 3. Where is option 3? Here. In the option B as well as in the option C, 3 is in the first position. Next, what happened? The elongation of what? Elongation of nucleus will be taken place. Elongation of nucleus will be taken place. Where the elongation of nucleus?
Excuse me, ma'am. Ma'am, your voice is breaking. I think your network is poor right now.
Is it audible now?
Yeah, ma'am, it's clear now, ma'am.
Is my voice?
Yes, ma'am.
So yes, thank you. So these are the events are going to happen in amoeba by during binary fission. So first is normal cell undergo the elongation of nucleation of cytoplasm will take place. Then the two cells will be there. I think 3. Yes. Here what happens? The nucleus are going to ready for the division. That is that diagram is skipped in this diagram. So here what happens? Normal amoeba carrying a normal processes, that will be that cell is ready. You know that cell division. The cell division, in the process of cell division, cell cycle, cell has to be ready in the G0 phase, S phase, and G2 phase. Here also cell is getting ready, and then the elongation of nucleus taken place, then the cytoplasm division taken place, finally leads to what? Resulting in a 2 cells. That is option C will be the answer for this. Yes. Yes, in the that is self-fertilization and cross-fertilization columns will be there. In this type of questions, we have to choose the proper answers, like match the following questions are these things. See, sponge is going to produce what? Sponge is going to produce gemmules, and yes, sponge is going to produce gemmules, and yeast is going to reproduce by the budding process. Yes, potato will be going to reproduce by tubers, and water hyacinth are going to vegetatively propagate by offsets. So this is the correct combination of this. Match the following. Sponge, that is 3, option 3, where it is. Yes, see, in this type you can guess the answers, like if you know only 2 out of 4, and you can guess the answers, like see, in this A, that is option is 4, and this is also option is 4. So we are going to eliminate these 2 options, and we have to choose from these 2 things. And right option is what? See here, like see, as you know that this sponges are going to produce the spores, that is gemmules. And water hyacinth, here it is water hyacinth. So this is by offset, this is the offset. Yes, and potato is by tuber, and this hydra by budding. Yes. Then next question is, genera like Selaginella and Salvinia produces 2 kinds of spores. Such plants are known as, in what we call for the those types of plants is, see, it is called as what? As I told, there are 2 types of spores will be present. That is homosporous and heterosporous. Homosporous means same type of spores, and heterosporous means different type of spores. Yes, so here it is, will be, there is the genera like this Selaginella as well as this Salvinia are going to produce 2 kinds of spores, that is different spores. Those are called as what? Heterosporous. If they are going to produce same type of spores, then we have to choose this homosporous. But here it is a thing, different kinds of spores are going to produce, that is called as what? Heterosporous. Yes, vegetative propagule in the agave is termed as. Anybody want to answer? Yes.
Ma'am, students have already shared their answers in QA box.
Okay, I'll check. Sorry.
Yeah, ma'am.
Yes. Preetham, right? Agave will be propagule. The vegetative propagule in agave is bulbil. This is the right answer. Yes. See, this is the picture of bulbils. These bulbils are the vegetative propagules in the agave plant, right? Yes. Strobilia cones are found in Teres, Marcantia, Equisetum, and Salvinia. What's your answer? Strobilia cones. Which plants are going to have cones or strobilis?
My maximum answers are for B.
What is that? B. Marcantia. Students, in Marcantia, it will be having not strobili, that is antheridiophore and archegoniophore. It is a dioecious plant, right? It will be having different reproductive structures, like antheridiophore is a male reproductive structure, as well as archegoniophore is a female reproductive structure. Yes, Right answer for this is what? Strobilus are not. Strobile is, what do you mean by this? Strobile is nothing but spore bearing organs. Those are present in equisetum. So this is the structure of, this is a plant of equisetum. In this equisetum, see here, this is what? The structure, that is a spore bearing organ. Here it is a spore bearing organ, that is a strobilus, or cones. These cones are also present in gymnosperms. In gymnosperms are also, you are going to see the cones, male cone and female cone you are going to find. In equisetum you are going to find the spore bearing organism, that is strobilus, right? Not in Mercantia. The right answer is what? Equisetum. Right answer is equisetum. Yes. Refer the given pictures and select the correct option. C and D reproduce by budding. See here, C is hydra and D is yeast. They are going to reproduce by budding. That includes nuclear division only. They are specifying that nuclear division only. And option B, all of these reproduce by asexual mode of reproduction. B represents a multiple fission in algae. Is that algae? Is this diagram is algae? A shows spore formation in Monarian. Yes, we have to select the right option. All these organisms are going to reproduce asexual mode of reproduction, right? What's your answer? Option B. Pooja. Yes, all these organisms are going to reproduce by asexual method. Yes, Kavya, Lakshmi, right. Suma, right. Yes, we shall move on to the next question. Yes, all these organisms are going to reproduce asexually. See here, this is regarding hydra. The given figure hydra shows its reproductive structures and manner of fertilization. Observe and answer that why it is not showing self fertilization. The distance between the testes, see here it is a testis and here it is a ovary in a hydra. The distance between testis and ovary is more, and sperms do not swim downwards. Ovary matures earlier than testis. Testis mature earlier than ovary. See here in this diagram what happened. Ovary is not receptive till here the sperms are matured earlier. Yes, somebody answered, I think. Pooja A, Rakesh A. No, students, the distance doesn't matter. Distance doesn't matter between the reproductive structures like gametes. If the gametes are having the flagella for their locomotion, distance doesn't matter. Yes. So here the testis mature. Here, see here it is ovary, it is not receptive till. That's why then this is called as what? Outbreeding devices we can call for this process. That is ovary matures earlier than testis, or testis are going to mature earlier than ovary. All these things. Yes, someone answered D. Yes, option D. Yes. Option D is the right answer, because here the sperms are releasing, ovary is not till receptive. That's why it is going to fuse with the other hydra ovary. That is the thing is this. So that's why the answer is, yes, you are right. Option D is the right answer. This is the right answer. And then We shall pass on to the next question. A few statements regarding the sexual reproduction are given below. Sexual reproduction does not always require two individuals. Is that right answer, the right statement? Sexual reproduction generally involves a gametic fusion. Meiosis never occurs during sexual reproduction. External fertilization is the rule of sexual reproduction. Choose the correct statement. From the options below, they are telling that according to sexual reproduction, what happens? Usually it involves the fusion of gametes. That is, as our definition says, what is that? Sexual reproduction generally involves gametic fission, that is formation and fusion of gametes. Meiosis never occurs during sexual reproduction. Yes, it is right statement, because somebody answered. Option B, G1, option C. Shahin raised hand. Okay. Yes. See, meiosis never occurs during sexual reproduction, but meiosis occurs during gamete production. That's why this statement is also right. External fertilization is a rule during sexual reproduction. No, usually in sexual reproduction, what happens? Internal fertilization happens. So option, yes, 1 and 2. See, Lee, what happened here is the number. Sexual reproduction does not always require two individuals, because hermaphrodites also present. So this statement is also right. And meiosis never occurs during sexual reproduction. Meiosis occurs during sexual reproduction during the time of what? Gamete formation. So 1 and 2. This one, statement 1 and statement 2 is correct regarding sexual reproduction. Yes. The statements given below describe certain features that are observed in the pistil of the flower. Pistil may have many carpels. Each carpel may have more than one ovule. Each carpel has only one ovule. Pistil has only one carpel. Anybody wants to answer? Yes. B, C, D, B. Okay. See here in this question. Yes. You can see here, this is what the structure of carpel, one carpel, right? Pistil may have many carpels, right? Pistils may have many carpels. This is what the pistil. Pistil is a unit of, pistil is what? A female reproductive thing, that is a compound pistil is fused pistil. This pistil are going to have many carpels. These are what? Carpels. This is one carpel and this is another carpel. This carpels, the units of pistil are called as what? Carpels. One pistil may have many carpels. This is the right statement. And each carpel may have more than one ovule. Here you can see in this picture itself, you can see this is one carpel. In this carpel you are going to see many ovules. This is not right answer. That is a right statement. That is, each carpel has only one ovule. In many species of plants, carpels are going to have more than one ovules. Pistil has only one carpel is also not right answer. That is, option for this is right option for this answer is option A. Option A, statement 1 and 2 are correct. true statements. Yes. Yes, we shall pass on to the next question. Which of the following situations correctly describe the similarity between angiosperm egg and human egg? They are asking. See, eggs of both are formed once in their lifetime. Both the angiosperm egg and human egg are stationary. Both angiosperm egg and human egg are motile and transported. Syngamy in both results in the formation of the zygote. See here, this is the structure of what? Angiosperm egg, and this is the structure of human egg. See, when compare, here it is a structure of egg cell. It is what? Both angiosperm egg. See here, this is an angiosperm egg, as well as this is a human egg, are stationary. In sexually reproducing organisms, eggs are what? That is in angiosperm as well as in human beings, eggs are what? Stationary and larger in size. And syngamy results, that is the fusion of this male gamete and female gamete, this egg with the sperm and this egg with the pollen gives rise to what? Zygote. Yes, so that is option, that is statement 2 and statement 4 are correct, the right options. Where it is? Yes, option A is the right answer. This is the right answer. And then next question. There are various types of reproduction. Types of reproduction adapted by an organism depends on. Types of an reproduction of an organism depends on the habitat and morphology of the organism, morphology of the organism, morphology and physiology of the organism. Option D is organism's habitat, physiology, and genetic makeup. See, types of reproduction, that is asexual reproduction, in that types, sexual reproduction, these types are selected, these types are chosen by an organism that depends on organism's habitat. And also, why I'm saying organism's habitat is some organisms like crocodiles, in some reptiles, the temperature may also depends, temperature may also decide the gender of organisms, that's why. And physiology of an organism, and also in sexually reproducing organisms, genes are very important. That is the organism's habitat, physiology, and genetic makeup of an organisms depends on depends the types of reproduction they are going to follow. Identify the incorrect statement. This is about, these statements are about reproduction. In asexual reproduction, the offspring produced are morphologically and genetically identical to the parents. They are asking incorrect statement. Is this statement is incorrect? It is a correct statement. Anybody want to answer this question? I think somebody had answered. Option D. Option D, option D, option D. Yes. They are asking incorrect statement, students, not correct statement. You are answering like answer D, that is option D. Conidia are asexual structures in penicillium. Conidia are asexual spores producing in penicillium. That is the right answer. Somebody answered right. Kirtana right. Jeevan right. Yes. Sirisha right. Viresh right. Yes. Zoospores are sexual reproductive structures. It is a wrong statement. In the, as I told during the what is that spore formation, there are two types of spores, that is types of spores, planospores as well as zoospores. Among all types of spores, these spores are what? Asexually reproducing spores. Planospores as well as zoospores are asexually reproducing spores. Other spores are what? Sexually reproducing spores are there. These are not asexual. These are not sexually reproducing spores. These are asexually reproducing spores. So this is the right answer. They are asking incorrect statement. You have to concentrate on the question. They are asking whether incorrect or correct statement. Right? Which of the following statement is incorrect? Here it is again incorrect statement. They are asking incorrect statement. Read on the statements. Try to answer. Claviceps is a source of many alkaloids and LSD, and conidia are produced exogenously and ascospores are produced endogenously. Yeasts have filamentous bodies with the long thread-like hyphae. Morels are truffles are edible delicacies. So among these statements, which is a wrong statement, which is an incorrect statement? Yes, option C, right? Arya, right? Kavya, right? Pooja, check once. Yes, option C is the right answer because yeasts are not. See, this is the view of what yeast. This is how yeast looks like. Yeasts are not filamental bodies. Fungus are filamental bodies. These are what yeast looks like. That is. So here C is the right answer. They are asking incorrect statement. That's why. Yes. Which one of the following statement is not correct? Here also they are asking what? Not correct statement. Offspring produced by the asexual reproduction are called clones. Microscopic, motile, asexual reproductive structures are called zoospores. In potato, banana, and ginger, the plantlets arise from the internodes present in the modified stem. Water hyacinth growing in a standing water drains oxygen from the water and leads to the death of the fishes. Among these, which is the right incorrect statement? Yes, 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 good. Pooja, D is not the right answer. They are asking incorrect statement, students. They are asking incorrect statement. We have to choose incorrect statement. In potato, banana, and ginger, plantlets arise from the internodes present in the modified stem. In potato, the plantlets arise from the eye buds, eye tubes present in, and ginger also bud region, and banana rhizome region. See, these are the regions where plantlets are going to arise in potatoes, and in this region, what is this? Adventitious roots will be arising from the nodal regions, and these are the buds which are responsible for the arising of plantlets in ginger. That's why the wrong statement is, they're asking about wrong statement. That's why we have to choose the wrong statement. Wrong statement na choose madbeku. So this is the right answer. Yes. Study the following figures and select the correct statements regarding these. A shows, see, it is A. This is A, this is B, this is C, and this is D. Right? Yes. Now read the statements. A shows mode of asexual reproduction in sponges through internal buds. B shows sexual reproduction through zoospores in Chlamydomonas. C shows asexual reproduction through conidiophores in Penicillium. D shows external budding in Scion. See here, what is this diagram? This is what? Chlamydomonas diagram it is. They are given a statement like Chlamydomonas zoospores. See, zoospores are not sexual. Zoospores are asexual. Apart from these, all statements are true. Here, see here, we have to choose the right statement. Somebody answered. Option D. Yes. Kavya Nagraj, right? Bhavna, right? Spandana, right? Yes, students, right. D is the right option. This is the right option. That is statement 1 is right. 1, 2, and 3 are right. Statement B is wrong. Yes. Yes. Which of the following plant is monoecious? Which of the following plant is monoecious? They are asking. What do you mean by monoecious plants and dioecious plants? Here it is a diagram of, here it is a picture of what? Markantia. Markantia is having, see, this thallus is having what? This archegoniophore. Archegoniophore is a female reproductive structure, and this thallus is having antheridiophore. Antheridiophore is a male reproductive structure. This is female reproductive structure. These thallus are what? Separate. This thallus is having antheridiophore and this thallus is having archegoniophore. And also in papaya, you can see the flowers, male flowers and female flowers are different. And also in they are giving Carica papaya. See here, the Carica papaya is the scientific name of what? Papaya. And Markantia polymorpha is the scientific name of this Markantia plant. And Cycas cercinalis. See, this is the scientific name of Cycas. Here you can see the plants, different plants. That is, here it is a male cone and it is a female cone. These cones are born on different plants. Those plants are called as what? Dioecious plants. And what about this monoecious plant? See, monoecious plant is Cara. Yes, answered. Good. Yes, Cara. Answer Cara is right. Answered. Anu, Pooja, check once. Carica papaya is having dioecious. It is, see, it is female flower and it is male flower. These flowers are going to born on different plants. So answer for this is what? Cara. See here it is. This is what? The oogonium. Oogonium. It is oogonium. And this is antheridium. Male sex organ, female sex organ present on the same thallus itself. That's why these are considered as what? Monoecious plants. Answer for this is Cara. Good. Yes. Which of the following flowers only once in a lifetime? Flowers only once in a lifetime. Mango, jackfruit, bamboo species, papaya. I think this is very easy. Answered. Yes. Whoever answered option C, that is right. That is bamboo. Bamboo is what? The only species. Yes, bamboo is the only species. Have you seen the flower of bamboos? See, these are the flower of bamboos. Yes, right answer for this is what? Bamboo species. Which one of the following generates new genetic combination leading to variation? Vegetative propagation, parthenogenesis, sexual reproduction, nuclear polyembryony. See, anybody answered? Option C, 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 yes, C. Yes, yes, good, good. Whoever answered C, that is right. Sexual reproduction only gives rise to what? Variations. These are vegetative propagation, even parthenogenesis, nuclear polyembryony. These are asexual type of reproductions. We can't expect Match the column 1 with column 2 and select the correct options using the course below. See, sing carpus, right? Yes, pistils. Anybody answered? Yes, someone answered. Option B, option D. Yes, B. Option D, Arya, right? Yes, who had answer option D, that is the right thing. See, pistils fused together, we call it as what? Syncarpus. And formation of gametes is nothing but gametogenesis. Hyphae of fire ascomycetes are what? Dikaryotic. And unisexual female flowers are called as what? Pistillate flowers. So this is the right answer. Who had option D? That is the right answer. Yes. Product of sexual reproduction generally generates. Answer this question. Longer viability of seeds, prolonged dormancy, new genetic combination leading to variation, large biomass. Product of sexual reproduction generally leads to, yes, answered. Yes, new genetic recombination. Good. New genetic recombination, because the sexual reproduction leads to variation. Sexual reproduction leads to what? Variation. Because here, see, ovum will be having 23 chromosomes and sperm will be having 23 chromosomes. That gives rise to 46 chromosomes. This happens in plants also. Yes. Why is viviparity undesirable character of annual crop plants? Yes, it reduces the vigor of the plant. It adversely affects the fertility of the plant. The seeds exhibit a long dormancy. The seeds cannot be stored under normal conditions for the next season. What is the answer? Viviparity is undesirable character for annual crop plants. Yes, answered. Option B, option D. Hemant, right? Yes, see here, vivipary doesn't reduces the vigor of the plant, and it doesn't also affect the fertility of the plant. See, the seeds of this viviparity, that is annual crop plants, are not able to store under normal conditions. Special conditions must be needed for the preservation of the annual crop plants. Who are answer option D? Right answer. This is the right answer. In ogamy, fertilization involves. What do you mean by this ogamy? See, there are types of gametes are going to produce. See, isogamy means types of two types of gametes are similar in structure. Anisogamy means that is heterogamy, two types of gametes. Here it is a one gamete and here is another gamete. One is large and one is small. Ogamy in the sense, both are having what? Flagellas. Here in isogamy as well as anisogamy, both gametes are flagellated, that is motile. Here in ogamy, the female gamete is what? Female gamete is larger and non-motile. Male gamete is smaller and motile. Where it is the option? Answered. Yes. Yes, good. Good. Option B. Option B is the right answer. Yes. Large non-motile female gamete and small motile male gamete. That is called as what? Ogamy. Anisogamy means larger female gamete, smaller male gamete. Both are flagellated. Isogamy means production of what? Both gametes are similar in appearance. Yes. Following table summarizes the difference between self-fertilization and cross-fertilization. Pick out the wrong differences. Yes. See, we have to pick the wrong differences here. Self-fertilization is uniparental, right? Yes, it is right. Cross-fertilization is biparental. Yes, it is also right. It involves the fusion of male and female gametes of the same parent. Yes, that is the definition of self-fertilization. Cross-fertilization, it involves the fusion of two gametes produced by two different parents. Yes, and option C is example Peritema periplaneta, Tania rana tigrina. See, self-fertilization. Answered option B. Option B, option D, option D. Option B. Option B, no. Cross fertilization, self fertilization definitions are right. See, Tania solium. Here it is a given example, Tania. That is, this Tania is a scientific name of what? Tania solium, tapeworm. Tapeworm is what? Unisexual organism, right? In the unisexual organism, no cross fertilization will be happen. So that's why this is the right answer. Wrong difference they are asking. That's why this is the answer. For previous question, the answer is option C. Yes. See here, they are asking about what are these parts? A, B, C. A is what? A is, here it is A, endothecium, these are middle layers, and this is what? The tapetum. See, this is the structure of what? Anther, right? Where it is the right option? Yes. Which are recently answered? Option C is the right answer. Yes, option C is the right answer. For this question, option C is the right answer. See, this is what the middle, these are what the middle layers. These are what the middle layers. These are middle layers, and this is what? The endothecium. This is the cell wall. Epidermis. This is the epidermis. They are not mentioned epidermis. And C is what? Tapetum region. In condition, both male and female flowers are born on the same plant. An example of such plant is, see, male and female flowers are born on the same plant. Those are called as what? What do we call for those plants? See, in this question, they are asking about the conditions. See, monoecious cucurbit, monoecious papaya, dioecious cucurbit, dioecious papaya. Both male and female flowers are born on the same plant are called as what? Monoecious, right? Monoecious. Is papaya is monoecious? Both male and female flowers are born on the same plant is an example of such plants is, such plant is, okay, yav condition, monoecious condition, yavralide, cucurbits alide. Yes. See, this is the structure of what? Embryo sac of angiosperm embryo sac, right? Here we have to identify the parts. See, this is the thing. Yes, this is the embryo sac. This is a micropylar region. In this micropylar region, this angiosperm embryo will be having 8 nucleated 7 cell stage. I think you all know about that. These are what antipodal cells. These are polar nuclei, and this is called as what central cell. And here it is a presence of egg cell, that is female gamete, and these two are synergids. There is a presence of filiform apparatus, which is a root map to the growing pollen tube, right? So this is the structure of embryo sac. See, A is antipodals, C is egg, B are synergids, D are filiform apparatus. Yes, yes, right. Whoever opted option B, that is the right answer. Option B is the right answer. Option B is the right answer. Yes, this is the structure of what? Monocot embryo. Yes, monocot embryo. The structure of this monocot embryo, we have to select options like what is A? Here it is A. What is A? Scutellum. And what is B? Yes, this is coleoptile. And what is C? What is B? C is coleoptile and B is coleorhiza, right? Yes, this is scutellum. These are what? Coleoptile. Shoot apex. The protective layer to the shoot apex is called as what? Coleoptile. That is plumule. Gives rise to shoot apex, and radical gives rise to root. There is a presence of root cap protection to this radical region, and there is a outer region of this root cap is called as what? Coleorhiza. A is scutellum, B is coleorhiza, and C is coleoptile, where it is in the option A. C is coleoptile and B is coleorhiza. Yes, in the option B it is. This is the right answer. Yes. What is the function of filiform apparatus in an angiospermic embryo sac? See, this is an angiospermic embryo sac. These are what? Synergids. In the synergid region, there is a presence of what? Filiform apparatus. As I told, this gives a way to the pollen tube, guides the pollen tube from synergid to egg. This is the function of this synergids. Helps in the entry of pollen tube into the synergid. No, filiform apparatus guides the pollen tube from synergid to egg. It doesn't prevent the pollen tube. It brings about opening of the pollen tube. No, it doesn't bring about that. So answer for this question is it guides the pollen tube from synergid to egg. Next question is identify the parts labeled as A, B, C, D and select the correct option from the codes given below. 34th question, that is A, B, C, D are mentioned here. See, what is this? A is A is seed coat and B is what? Scutellum, not scutellum. Cotyledon, not cotyledon. Yes, endosperm. And C is, here it is, cotyledon. These are cotyledons, and this is what? Epicotyle region. Where it is in option D. In bio, you're going to see this type of questions, that is diagram based questions. That's why you have to study diagram as well, right? The term used for the transfer of pollen grains from anther of one plant to stigma for different plant, which during pollination brings genetically different types of pollen grains to stigma. This type of pollination is called as what? This type of fertilization is called as what? Yes. 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 No. See, this is called as what? A xenogamy. This is called as xenogamy. Transfer of pollen grains from anther of one plant of stigma of different plant, that is to different plant, that is called as what? A xenogamy. Yes, diadelphous stamens are found in this. Adelphous condition is the bundles. Adelphous means bundles of stamens. If the stamen is present in only one bundle, it is called as what? Monoadelphous. If stamens are present in two bundles, see here it is one bundle, this is one bundle, and this is another. This type of arrangement of stamens is called diadelphous. And polyadelphous means many groups are there in the stamen. And syngenetious is what? The groups. The stamens are what? Fused. Here the anthers are, filaments are fused, anthers are free. That is syngenetious condition. Syn-androus condition is what? Anthers are fused, filaments are fused, anthers are free. That is syn-androus condition. See, diadelphous condition seen in diadelphous conditions seen pea plants. Next question. A typical angiosperm embryo sac at maturity, it will be having how many cells and how many nucleus? See here, this is a typical angiospermic embryo. It will be having how many cells? See, this is one, 2, 3, 4, 5, 6, 7, and here it is 8. How many cells are there? 8 cells are there. How many nucleus are there? We will count. 1, 2, 3, 4, 5, 6, 7, 8. Yes, anybody answered? Sir, can you please clear the previously answered answers?
Ma'am, I've already cleared, ma'am. I think you have to clear from your side also and dismiss the answers, ma'am.
Okay.
Because I've cleared all the answers from here. Ma'am, please try reopening it once.
Yes.
The question answer box.
I can't do anything, I think.
Just a minute, ma'am.
Students, to this question, typical angiosperm embryo sac will be having how many nucleus and how many cells?
Ma'am, most of the students have answered A.
Yes, that is the right. 8 nucleated and 7 cell stage. Yes, that is the right answer. Yes. In some members of which of the following pairs of families pollen grains retain their viability for months after release? See, in the plants which are belong to the Rosaceae and Leguminosae plants, they are having viable pollen grains. Anybody answered?
Yeah, ma'am. Answered D, ma'am.
Yes,
Everybody
that is the
answered D.
right. Yes, that is the right answer. D is the right. Which of the following is incorrect for wind pollinated plants? These are the statements about wind pollinated plants. That is, you know that pollination will be happen by so many things like biotic factors and abiotic factors. Biotic factors like pollination will be taken place by insects, birds, all these things, and abiotic factors, wind pollinated pollens will be there, water pollinated pollens will be there. What is the answer for this question? Well exposed stamens and stigma, many ovules in each ovary. Flowers are small but do not brightly colored. Pollen grains are light and non-sticky. See, they are asking the incorrect statement.
Ma'am, most of them have given B and D as answer.
Yes, whoever answer option B, opted option B is the right. Many ovules in the each ovary. The number of ovary is not the criteria for pollination. Only the characteristic of pollen will be considered for the pollination process. So option B is the right answer. They're asking incorrect statement, right? That's fine. All these things, well exposed stigma and not brightly colored, and pollen grains are light and non-sticky, are the characteristics of what? Wind pollinated flowers. In water hyacinth and water lily, pollination takes place by water current only, wind and water, insects and water, insects and wind. What's your answer?
Ma'am, D.
Yes.
A.
Yes. D is the right answer. Insects and wind. See, these are what water hyacinth and water lily. Here, stamens are exposed from the surface. That's why insects and wind will be the pollinators here. The plant part, which consists of two generations within the other. Pollen grains inside the anther, germinated pollen grain with two male gametes, seed inside the fruit, embryo sac inside the ovule. What will be your answer? They are given the statement. Have to choose from the statement.
Ma'am, B.
B.
B and Ashwini Sajan has given A.
See,
Other
they're
than that, everyone is getting
asking,
B.
they're asking two generations, one within the other, right? See, in pollen grains, in anther, there are pollen grains are present. Then in seed, in embryo sac, ovule is present. Embryo sac, ovule is present, anther, pollen grains are present. These are going to have the two generations. That is, one will be going to reproduce, and this embryo sac will be having ovule. That is also involved in the process of reproduction. This pollen grains are also involving in the process of reproduction. See, this is what germinated pollen grain. This is after what? Gametogenesis, and seed inside the fruit after fertilization. So right answer is option C. Right answer is option C. 1 and 4th statements are true. Yes. What type of pollination taken place in Vallisneria? Pollination occurs in submerged condition by water. Flowers emerge above the surface of water and pollination occurs by insects. Flowers emerge above the water surface and pollens are carried by wind. Male flowers are carried by water currents to the female flowers at the surface of water. this is a very good example for hydrophily, right? Vallisneria. Answered anybody?
Yeah, ma'am, D answer.
Yes, D is the right answer. Yes, D is the right answer. See, this is how Vallisneria will see here in the surface. Female flowers are there, and in the region, male flowers will be there. The male pollens will be carried by water current itself. Yes. In which of the following both autogamy, getinogamy are prevented? They're asking. See in this picture. See, this is what the autogamy. Pollen transfer from same flower. Pollens transfer within the same flower. This pollen will be transferred to the stigma of this flower only. So this is called as what? Autogamy, right? See, next is what? Getinogamy. Pollen transfer of pollen between the flowers of same plant. See, these two are the flowers of same plant. This process is called as what? Getinogamy. And this is the picture of what? Xenogamy. Transfer of pollens between the flowers of different plant individuals. This flower belongs to different plant, this flower belongs to different plant. See, in which of the following both autogamy and getinogamy are prevented? They're asking. See, in papaya, because in papaya there are two papaya is what? Having male flower and female flower in a different plants. That's why in papaya, autogamy and getinogamy are what? Prevented, right? Answer is papaya.
Ma'am, we'll continue or we'll stop now?
We'll stop. Only this one.
Okay, ma'am.
Okay. Pollen grains can be stored for several years in a liquid nitrogen having temperature of, what do we call for this process, students? Cryopreservation, right? Anybody answered?
Ma'am, they've answered option A.
Yes, right. Option A, minus 196 degrees centigrade. In minus 196 degrees centigrade, in the liquid nitrogen, we are going to store the pollen for several years for further research purposes. Right? So this is what about cryopreservation. Yes, we shall stop here. I hope you're all understood about today's class.
Ma'am, I think students liked your class a lot because there were more number of students who were answering today.
Yeah.
So it was a wonderful class, ma'am. Thank you so much, ma'am.
Thank you so much.
Ma'am, tomorrow also you have a class in the second hour.
Sir, that have to by sir.
Yeah, ma'am. No, ma'am. I'm just informing. Like I got the timetable. I need to inform the students also. So I thought I'll inform you also that.
Okay. I'll confirm you, sir. I'll confirm.
Okay, ma'am. Okay, sure, ma'am.
Okay. Thank you. Thank you,
Thank you,
students.
ma'am. Thank you so much, ma'am. Students, thank you so much for attending the class. It was a wonderful class. You guys did well. You guys answered so many questions today. Also, if you need any help or any such kind of queries, if you have, you can contact our helpline number, and also you can mail us at dsu-career-advisor@dsu.edu.in. Also, if you want to download your materials and notes, you can download from the given link. And also the recorded session has also link has already been mailed to you and WhatsApp. So I hope you guys don't have any doubts further.
It's already late. Where's Arjun?
He's looking for universities, right? Maybe he's held up there.
You look so tense. By the way, did you get to choose the university?
No, I'm unable to find a university that meets my requirements.
Whoa. Meet your requirements? What exactly are you looking for?
I'm looking for a place that gives me an opportunity to grow, to excel, to invent. and to innovate. I want to be a part of an institution that paves my way to discover myself and to witness the world moving forward in technology. I want to go to a place that sets a futuristic pattern of education filled with ideas and radical performances. Basically, I want to live my dream.
Dayanand Southern University. Live the dream.
Okay, so students, tomorrow you have to log in again at 8 o'clock. First hour you have physics by Satish sir, and second hour you have biology. And if you want the timetable, you can again go to the helpline number, and you can mail on the given email ID, and you can get the timetable for